Okay, Ken. So let's go through the questions you did. I realized that you did until question 12. Good, good. Okay, now I'll just go through. Question 7, part A, we already went through, nothing wrong. Part B is fine. Part C also okay. Part D, yeah, you forgot. Must remember, when you have change, when you integrate by substitution, the limits here, can you see the limits? Oh, why is my highlighter not working? Sorry, give me a sec. Okay. What was I saying? I'm saying when you have a when you use a substitution, right? You must make sure to find out the upper and lower limits. Remember this? Mic test, can you hear me?
Okay.
You must remember to change the limits from the X world into the U world. Okay. So when you let U equals to, strongly recommended that you should write down like X equals, sorry, in this case, it should be X equals tangent theta, right? You're going from the X world into the theta world. So you need to solve for U. Oh, sorry, not U. My apologies. It should be a theta. Follow the question. Sorry, I'm too used to using U already. It should be a theta in this case. Oh. So how do you calculate this? Do you know how I got pi over 4 and 0?
Is it tangent inverse?
Yes, correct. That's all. Right? Just solve for theta. Okay, so must remember, must change the limits, okay? Upper and lower limits. If not, we'll have error carry forward. You see, you go from the dx world into the d theta world. So the limits here should be changed from xx to theta theta. So what I like to do when I do integration with limits, right, is to write down the following. X equals, to remind myself I am currently in the x world. Then if I do a substitution already, I go from x to the theta world, I must write down theta equals. And it's impossible that the theta will stay the same. Okay, maybe coincidentally in some questions they will be the same, but usually not. You need to calculate. And also another point to take note is don't blah blah. Upper limit is upper limit, lower is lower. Some students will mix it up. You end up writing 0 on top and pi over 4 below, which is wrong. Okay, clear? Good. Okay, then this question, over here up to here, it's perfect, good. But then here, when you try to integrate 2 over secant square, it is not the same as 2 over tangent x. I think what you are remembering is differentiating tangent x gives you secant square, right? But over here, it's 1 over 1 over. The moment you got a reciprocal, it changes things drastically. You can no longer apply the same logic. So let me give you an explanation. So in general, if you try to integrate a little f of x and you get a capital F of x, and this is true, let's assume, when you try to integrate now the inverse, the reciprocal version, 1 over the little f, then you have to do it case by case already. It's not just 1 over capital F. What do I mean by that? Let's take a look. Secant square first. Fx equals secant square. So what we have is integrate 1 over secant square. 1 over secant square, I hope you know that it's really just cosine square. Yes?
Yeah.
Then in cosine square power 2, you have to use power reduction. Look at my ultimate list. Maybe if I can find it for you. Go back to the ultimate list, ultimate summary or whatever I call it. Over here, these 11 and 12. This is called power reduction. Power reduction. You are reducing the power from power 2 to a linear power 1. Cosine 2x is like an invisible power 1. Can you see? Power 2 drop to power 1. Power 2 drop to power 1.
Yeah.
That's called power reduction. Must remember this pattern. It's basically derived from cosine 2a, the formula. You just have to make use this and make sine square the subject, or use this and make cosine square the subject, and then after that you just sub in. Can?
Can.
Yeah. So yeah, then after that you just have to do power reduction later, then I explain. But let's try another example. If fx equals to x, then what's integral of 1 over x?
It's ln.
It's ln, right? Totally different, right? It's not just integrating x. What, you get x squared over 2, then you 1 over it. No way, right? It's not that simple. Right? Then how about if it's fx equal x squared plus 1 over 2x? Then in that case, 1 over this will be just flipping the fraction. So 2x over x squared plus 1. I hope you realize that numerator now I purposely designed it so that it's a derivative of the denominator. Differentiate x squared plus 1, you get 2x. Then now you'll just integrate this and you'll get ln of modulus x squared plus 1, right? In fact, actually, I can even change this into round brackets because I know that x squared plus 1 for all real values of x, it will just be positive. Right? This is how the x squared plus 1 graph looks. It's always floating above the x-axis, means it's always positive. Right? Yeah, so I don't even need I can drop the modulus in this special case because x squared plus 1 is already positive. Okay, this is called reverse chain rule. Then how about if fx equals to square root of x? Then you get 1 over square root of x. In this case, you just need to realize that square root of x, use your power rule, bring it on top. You get x power negative half. Yes?
Yeah.
Right? Then this is just algebra. Then after that, integrating x power negative half, just add 1 to get new power, divide by new power. You get x power positive half over positive half. Minus half plus 1 is positive half. Can?
Can.
Okay, so the conclusion here is do not simply flip it around. Not that simple, okay?
Okay.
Yeah, I know differentiating tangent is secant square. So if you integrate, then you work backwards. So integral of secant square is tangent. But integral of 1 over secant square is not 1 over tangent. Okay, not that simple. Clear?
Yeah.
Yeah. Sorry, my mouse. Yeah. Okay, moving on. So how do you actually do it? So what you need to realize is that 2 over secant square, the actual question is 2 over secant square, simplifies, oh, wrong. Sorry, what happened? Okay, where am I? Oh, here, sorry. Yeah. Yeah, here. So integrating 2 over secant square is not 2 over tangent x. What you need to realize is that 2 over secant square is actually just 2 times of cosine square. Right? Then after that, you can use the formula. Cosine square is really just, if I zoom in, cosine 2 theta plus 1 divided by 2. Right? How to derive it? How I remember it is like this. You look at the formula list, cosine 2a is cos square a minus sine square a. Actually, hold on. Let me just double check first. Is it actually available in the formula list? Let's see. It is. Over here. Right?
Yeah.
Oh, by the way, in the formula list, please help me to, if you have printed a copy, please write down for me the sine square a plus cos square a equals to 1. Call this equation 1. Then you take 1, you divide throughout by sine square a. You get what? 1 sine square divided by sine square, right? Sine square divided by sine square, you get 1. Cosine square divided by sine square, you get what? Cotangent square. And 1 over sine square is cosecant square. This is not available in the formula list. Must memorize. Okay.
Okay.
Likewise, 1 divided by cosine square, sine square divided by cosine square, you're left with tangent square. Cosine square divided by cosine square is 1. 1 over cosine square is secant square. Can? Or learn to just memorize one guy, then learn the trick. Divide by sine square, divide by cosine square. So you have less things to memorize. Oh, not so stressed out over memorizing. Just learn the technique. It's more important. Okay, then just derive these 3 formulas on your own. Can? Okay, good. Then yeah, so looking at cosine 2a, we got all these formulas. So how do we use it? How do we use it to convert from cosine square into this formula here? Very simple. You just need to know that there's a cosine square. So you want to substitute cosine square. So which version of the formula? Cos square a minus sine square a? Or is it 2 cos square a minus 1? Or is it 1 minus 2 sine square a? Which is more useful? 1, 2, or 3?
The second one.
The second one. So in that case, we will use 2 cos square a minus 1 equals to cosine 2a. Who do I want as a subject?
The cosine square a.
Yes, exactly. So here you need to peel it off layer by layer. Can you see that there's actually let's say there's a function here, fx equals to cos square x. Sorry, x. And then there's a g of x here, which is 2x minus 1. And this 2 cos square a minus 1 is actually just g of f of x. Can you see that? So what we need to do when we want to make fx, which is a cosine square, the subject, we need to bring the g over, g inverse. Right or not? Can you see that? You want to peel it off layer by layer. Start from the outside and then you work your way towards the inside. So you need to get rid of the g. In other words, there's a minus 1 here, there's a 2 times here. You need to get rid of it. Of course, it's just algebra. If you're confused, Are you confused by this? I hope you're not.
No.
You just bring the minus 1 over, so you get cos 2a. No choice, because you bring over minus 1, must change to a plus 1. Then how do you make cosine square the subject?
Divide by 2.
Divide by 2. So there you go. Don't need to memorize one. Just derive on your own. Don't need to stress. Just use the formula list and make cosine square the subject. So cos 2a plus 1 divided by 2. That's how you get from this to this guy. Take note that we changed the letter a here to a theta. Can see or not? Theta, theta. All right, so what happens next? You got 2 in front. So 2 divided by 2 cancel each other off. You're left with integral of cos 2 theta plus 1. Integral of cos 2 theta plus 1. Very simple. Right, we have reduced the power from 2 to 1 already. Now it's linear. Very easy to integrate cosine 2 theta, right? It's just half sine 2 theta. Remember, there's a half. Why? Because of what rule?
Like the chain rule.
Yes, because of chain rule. When you differentiate sine, what do you get? You get cosine. Then you copy everything inside. But 2 theta itself is a function, so you still need to multiply by a 2 because of chain rule. Right? Then in order to find the integral of cosine 2 theta on its own without the times 2, you have to bring the times 2 over to the other side. So you have to times half. Do you get what I mean by that?
Yes.
Yes, okay, wait, I think I better explain a little bit. Let's say I try to differentiate this half. Sorry, if I differentiate sine of 2 theta, it's actually just cosine 2 theta, but chain rule tells you have to multiply by 2.
Yeah.
So now if you try to integrate both sides, just like differential equations, integrate both sides, integral d theta, integral d theta, then what happens when you got integral and derivative? They will
Cancel out.
Cancel out. Then you're just left with the sine 2 theta equals to integral of 2 cos 2 theta d theta. Is this part clear to you? Differentiating, get an answer. Integrating means you get back the original.
Yes.
Yes, you actually needed to know this trick for one of the questions. Later then I explain. You must remember this.
And differentiate. Cancel out.
There's a part 1 that asks you to differentiate first. Something quite complicated. I forgot the question already. I need to find the question. Where was it? Question. Sorry. I marked it last night. I kind of forgot where was the question already. Part 1 was asking you to differentiate. Then after that, part 2, they ask you to hence use that result to find the answer to the integral. Do you remember such a question?
I think so.
Have. It's the same thing. Let me see if I can find it. Okay, I can't find it. Yes, question 11, part 1, section 1, question 11. Right? The differentiating the e power x squared. Later then I explain. Okay? Okay, yeah. Okay. So anyways, you get back sine theta equals to 2 integral 2 cos theta 2 theta. We actually want what? We want integral of cos 2 theta on its own without the 2. What do you do to the 2? Toss it aside. Throw away. So bring over. Okay, of course, step by step, you should actually factor out the 2 first. So this will actually be 2 times of the integral of cos 2 theta d theta. But since we got a factor of 2, now we can throw over to the other side. It becomes our times half. Does that make sense? So now because you throw over to the other side, that's why there's a half. Do you get why there's a half now?
Yeah.
Or in other words, divide by 2 because of chain rule. Must remember, this is actually from Amex. Okay, anyways, integrating plus 1, you get theta. Don't forget, in non-definite integral don't have upper lower limit. You just must put a plus c. Then that's your answer, right? So this is I'm integrating without the limits, but actual question was what? The actual question had 0 and 1. That's not correct. It shouldn't be 0 and 1. It should be pi by 4 and 0. Pi by 4 and 0, remember? Okay, maybe I change back to screen so you can see my writing. Yeah, 1 and 0. So here, not 1 and 0 anymore, should be pi by 4 and 0. Then you just need to substitute in the integral of 2 secant square, 2 over secant square with half sine 2 theta. Then this one is a minus 1, substitute in with a plus theta. Oh, sorry, with a minus theta. the first part, sorry, I mentioned wrongly. 2 over secant square integral should be half sine 2 theta plus theta. And this minus 1 here should be a minus theta. Then eventually the theta and minus theta cancel off. You're left with half sine 2 theta. You try to sub in pi by 4 and 0. Okay? Do that on your own now. Can?
Can.
Okay, can. Then part E. Same mistake. Over here, you forgot to change the limits. You see, you're in the theta world already. This is part. This is 7 part E, right? Let me scroll to the correction. I strongly recommend you to copy down the substitution, like write it above, so that it's easier. Then what happens? Over here, you need to find the limits, right? So same thing, upper limit at first is 3, lower limit is 0. So x equals 3, x equals 0. Then later on, you find the theta. Do you want me to show you how to find the theta?
Is it inverse? Like the sine inverse?
No, this one is okay, this one I better show you. Let's say x equals to 3, then in this case, x equals 3 sine theta, right? So 3 equals 3 sine theta. Divide by 3, you get 1 equals 1 sine theta. Of course, it's just sine theta. This is an extreme case. Remember the crash course on trigonometry solving equations? This one, can you sine inverse or not?
Must draw the...
Yes, correct. Draw a graph. So in this case, here is y equals to 1. There is y equals to sine x. If you are really, really bad at drawing graph, use a GC. Use a GC. But try not to. This one sine x, you must remember. Up, down, down, up. That's for sine x. Then cosine will be down, down, up, up. But anyways, you eventually get this one point of intersection here. We should focus within the what we call the principal range or principal domain, which is in between negative pi by 2 less than, okay, maybe I'll use x less than pi over 2. Can? Then in this case, okay, actually I'll include both. In this case, maybe not the negative angle, sorry, just a positive angle. Then that case, the answer here is actually pi by 2. Then 90 degrees. Sine pi by 2 will give you 1. Is that okay? Okay, good. Here is y equals sine x. Okay, that's how you get the upper limit. Then the lower limit, that one, x equals 0. So even easier. If x is equals to 0, then you get 0 equals 3 sine theta. Divide by 3, you get sine theta equals to 0. So how? Again, it's an extreme case of 0. What do? Draw a graph.
Look at the graph.
Yeah, just look at the graph, right? X-axis itself is already y equals to 0. Then you got sine theta. Then in this case, where's the intersection? Here, here, and here. Which one do you pick as a solution? Got 3 solutions and how?
The middle one.
No. You must look within this interval, okay? The principal range or principal domain, sorry. Then can you tell me what is the angle that satisfies this condition?
The 0.
0, yes, that's why the limit here should be a 0. Clear?
Wait, the range, they never give me though, so I must remember that it's always like that.
Yes, correct. You remember you kept on telling me about the principal argument?
Yes.
Principal range, yeah, that's the thing. Let me tell you what are the things you should remember. As a side note, focus on this part of the curve. So then how about cosine x? Let me draw it first. Focus on this part of the curve. Okay, and the last one is y equals tangent x. Like this, like this. Focus on this part of the curve. So what you realize is that for sine and tangent, the range of x values is the same, or what I like to call the domain. So from here to here and here to here. For tangent, it will be negative pi by 2, strictly less than x, strictly less than pi over 2. Cannot be equal because you will reach positive infinity, negative infinity, undefined. But for sine, it will be negative, no space, wait, let me drag it up a little bit. Negative pi by 2 less than x less than pi by 2, but you include pi by 2, you exclude negative. Or we try to keep positive as much as possible. Actually, sorry. Yeah, I'm wrong. I should include both because they are not colliding. They are different values. -1 and +1. Sorry. Let me change that. Yeah. There should be an equal sign here.
Okay.
Then for cosine, what would it be?
The 0 like
0
and
0 less than equal x less than equal.
Yes.
What angle?
Pi over 2.
Wrong. 1, 2, 3, 4. 90, 180, 270, 360. In terms of radians is 90, 180. 180 here. Pi. The reason why we select these as the intervals is because of the corresponding graph. Look at the blue color highlight. You notice that it's very special. What kind of function do we call this? Like usually trigo is like periodic. Very good. It's 1 to 1. Yes. It's a periodic function that keeps on repeating. So it's many to 1. But here, once we restrict it, it becomes 1 to 1. Okay. And also we try to keep it as positive as possible. You try any other intervals, it will be less positive. And we try to include the 0 as much as we can. All 3 intervals include 0. Okay. Yeah. Includes the 0. Then the alternative to cosine, right, would be if you include 0 would be this guy. It's still 1 to 1. Do you see that? The green one?
Yeah.
But it's negative. It will go from negative pi to 0, which is bad. We don't like negative numbers, so we prefer to pick the other half, the right half. So it's more positive. Okay, yeah. So likewise with tangent, okay, tangent only got one choice. If you want to pass through 0, it must be this range. This is this snake, this little portion. Okay, that's how I remember it. I draw a graph, then I highlight, and I highlight, and I highlight. Then I from the graph, I read off the angles. Okay? Okay. Yeah, that's how you change the limits for those extreme cases. Then you substitute in this part, it's okay for part E. Then here, you got this to this part, 9 minus 3 sine theta bracket square is okay. But what you need to do now is to use trigo identity. Okay, let me just show you the solution now. This is 7 part E. 7 part E. Oh, wrong file. Let me find the correct file. Okay, let me show you. So here's how you solve it. You start with x equals 3 sine theta. Here. Then you differentiate, you get 3 cos theta. Make dx a subject, 3 cos theta d theta. You got it so far. Then you sub in the x with 3 sine theta. Straight away here, what they did is x square, you see, is just equals to 3 sine theta bracket square. So a times b power 2 is just a square b square, right? So in this case, it would be 3 square sine square. What's 3 square? It's just 9. So 9 sine square theta. Sorry, I'm lazy. I usually say sine square without saying theta, but you should write down the theta. Okay. Understand now? Sorry, I'm lazy when I speak. Okay, I'll try not to be. Okay, so 9 minus 9 sine square theta. You now have a common factor of 9. So you can factor out the 9, right? You see that?
Can.
And then you end up with 1 minus sine square. What's 1 minus sine square? Theta?
Sine square theta.
Sorry?
Cosine square theta.
Yes, well done. Good. So this one, no choice, must memorize one. Okay, sine square plus cos square equals to 1. Or the more useful format, which is 1 minus sine square and 1 minus cos square. Let me go back to MF26. So what I mean is, this usually maybe is useful, but typically when you're doing integration, the purpose of it is to make sine square the subject. So this version is better. Alternative version would be cosine square as a subject. It's 1 minus sine square. So if you want, you can memorize. But I think don't need memorize. Just memorize one version, then make sine square the subject, make cosine square the subject. Learn the technique, more important. Okay, go back to the question. So now we got 9 cos square. Take a square root. What happens when you take square root? Think about it. This is actually a square root of 9 times square root cos square, right?
Yes.
Which simplifies into 3 cos theta, right?
Oh, yeah.
Actually, technically, when you take the square root, right, it should actually be the of a square. Right? I hope you know this.
Yeah.
Square root of x squared is actually just modulus of x by definition. You think about it. If x is negative, you square it becomes positive. You take the positive square root, it still stays positive. So that's why you need a modulus around. But over here, luckily for us, the limits we know that it's from 0 to pi over 2, which means that your cosine theta is inside quadrant 1, which means that it will be positive. So that means we can drop the modulus now. It just becomes normal round brackets, or we don't even need the bracket anymore. Clear? That's usually you will not need to deal with that. You don't if this interval was in let's say it was from pi by 2 to 3 to pi pi by 2 to pi in that case that's quadrant 2, right?
Yes.
90 degrees to 180, lower to upper. Then in that case you actually need to introduce an extra minus sign because cosine is negative, or rather you need to put modulus around cosine. Don't without negative, you put modulus around cosine. But typically for A levels, they will not be so evil. They will not be so evil. It will usually be in quadrant 1. The angles. Then the cosine will be positive. You can leave it alone. You don't ever need to put down modulus. Okay, moving on. So this 3 cos theta d theta, where did it come from? It's from replacing the dx. So now you get what? You get 3 cos theta, which is the square root whatever, multiplied by 3 cos theta d theta. What's 3 cos theta times 3 cos theta?
Cosine square theta.
No, 3 times 3 as well becomes a 9 cos square theta. Okay, now you can factor out the 9. So 9 integral 0 to pi by 2 of cosine square theta d theta. Okay, I think by now you are bored already. Cosine square d theta. Cosine square theta d theta. I'm sure you know how to do it already. It's just cos 2 theta plus 1 divided by 2. But you can factor out the over 2, the half. So you get 9 over 2 integral cos 2 theta plus 1 d theta. Now you can integrate them term by term. Integrate cosine 2 theta, you get sine 2 theta, but make sure chain rule divide by 2. Integrate 1, you get theta. Then sub in the upper limit, upper and lower limit, pi over 2 and 0. So you get sine of pi over 2 plus pi over 2. Then minus away 0 plus 0. Right? You have to minus sine, sine 0 over 2 minus 0, which is really just a 0 lah. Sine 0 is 0. So 0 divided by 2 is still a 0. 0 is obviously 0. Minus 0 minus 0, still a 0. So that's why they didn't write anything down. Okay? Okay, good. So also how did they get the pi over 2 and 0? They showed you over here lah. Just sub in x equal to 3 to the substitution here, and then you make theta the subject. Okay, upper and lower. Clear?
Yes.
Okay, good. So now you get simplify and you will get 9 pi over 4. Here the question requires you to give an exact answer, and that's also the A level requirement. So yeah, just this part here, solving for pi over 2 and 0, just be careful. Okay, draw graph. Draw graph. Okay, moving on. Wrong file. This one. Okay, what went wrong next? Part F. Again, you need trigo identity. Here, a square minus bracket a sine theta square is actually a square sine square. So this whole question you didn't continue with trigo identity. That's why you couldn't solve the question. Okay.
So sine square theta.
Yeah, the a times sine theta bracket square means it's a square sine square. Right or not?
Yeah.
So minus a square sine square. You got an a square in front. What can you factor out?
The a square.
Exactly. Then you get a square times 1 minus sine square, which is a square times a square times a square times 1 minus sine square.
Yes.
Okay, I think you cannot visualize. I'll just go straight into solution already. You need to get used to it. So this question is purposely designed so that it can interact with the square root very well. You see, in part E, I go back to part E. We have a square root. The reason being, we got a square root which is irritating to deal with, which is why we introduced this guy over here, x equals 3 sine theta. By introducing this guy, we force this to turn into a 9 cos square theta, which is really just a perfect square, right? You can interact well with the square root. It will cancel off neatly to get a 3 cos theta. Okay, so same thing over here. We also want to do the same thing. We want to make sure that something can cancel off with this over 2 square root. So here's how we proceed. First, you let x equal to a sine theta, that's given. Then after that, you just need to differentiate. So dx by d theta equal to a cos theta. This part okay, right?
Yeah.
Yeah. Just memorize only. Then now you just write down. Here is also, by the way, this is a what we call a indefinite integral. So just make sure to have a plus c at the end of the day. Later on, must have a plus c. Let me just write it down in case I forget. Plus c. Okay, so now you got a square, leave it alone, but the x square replaced with a square sine square. But then there's a square here and there's a square there. You can factor out the a square. Okay, hold on a second. Let me see what's going on. Maybe later then I factor out a square. But here you notice that there's a cos theta, right? Where did this come from?
I substitute the dx.
Correct. Good. Make dx a subject. The d theta bring over. So you get dx equals to a cos theta d theta. Okay, just one thing to take note. A very pedantic nitpicking point. Here, technically, dx over d theta is a symbol. It's not a fraction. You are not allowed to split it up mathematically speaking. But for the practical purposes of solving questions for A levels, just do it. Make dx a subject. Just pretend it's a fraction.
Okay.
Technical reason, if you want to know, it's about after A levels, you can go and look it up. Differentiation by first principles. If you're interested, by first principles. You can go look it out. This is just notation. It's called Leibniz notation.
Okay.
Not relevant. For A levels, just pretend it's a fraction. D theta bring over. Okay, then anyways, yeah, dx substitute with a cos theta d theta. Then after that, what did they do over here? So they realized that there's a 3 over 2. Why don't I just bring in the power, right? Because remember, hold on. No. Sorry. I'm doing it wrongly. I show you. Okay, do you understand how they got from here to here actually?
Yes, they factorize out.
A square first, right?
Yeah.
Before they bring in the power 3 over 2. Okay. Let me just do it step by step, show you. So a square minus a square sine square theta bracket 3 over 2. It is not equal to a square times 3 over 2 minus a square sine square times 3 over 2. You agree, right? A minus b to the power is not just a to a power minus b to a power. Instead, what you need to do is to factor out the a square first. So you get 1 minus sine square theta. And then this whole thing is raised to the power of 3 over 2. Clear? Then after that, you can bring in the power because now you have the format of a times b power m equals to a power m times b power m. Where capital A is the a square, capital B is 1 minus sine square. So you get a square to the power of 3 over 2 times 1 minus sine square theta bracket to the power of 3 over 2. Okay? Then what happens to your 2 times 3 over 2? The 2's will cancel off. Then you're just left with a power 3 multiplied by 1 minus sine square theta to the power of 3 over 2. But of course, 1 minus sine square is what?
The cosine square.
Cosine square. So that means this part here gets replaced with cosine square. So this is actually equals to a cubed times cosine square theta to the power of 3 over 2. What happens when you got a square and over 2?
Like cancel out.
Exactly, cancel out. Then you are left with a cubed times cosine theta to the power of 3, cos cube theta. You know, right? Cos cube theta is the same as cosine theta to the power of 3.
Yeah.
By the way, this is not equals to cosine of open bracket theta power 3. Are you aware of that?
Yes.
I think you got confused. You got confused in one of the questions. There was one part where you had to integrate cosine theta square. Or x square. They use x. In this case, this is, if you try to integrate this, there's a special name for it. It's called a Fresnel integral. It is a non-elementary integral. Too difficult for A level already. Okay? Too difficult for A level already. Here, you can avoid it by making sure you don't try to integrate this directly. Later, then I explain. You need a 2x in front. Then you can use reverse chain rule. But anyways, sorry, you got a question?
No.
No? Okay, great. Then here, this is the denominator only. A cubed times cos cube. But how come here is a square? What happened? How come cube becomes square? A got cancelled off, right? Why?
The
I thought it's A cube cos cube. From
from
the
the A cos theta, the numerator.
very good. You didn't get tricked. A cos theta, here suddenly no more A. It's because they cancel off one copy of A with the A cube here. Clear? That's how we get A square. Good. Then after that, the denominator just gets replaced with A cube cos cube, but one of the A cancel off, so it's A square cos cube. A square cos cube, but you factor out the 1 over A square. So you end up with numerator cosine theta. The denominator is a cos cube. What's cosine over cos cube? They can cancel off one copy of cosine. Then you're left with 1 over A squared times the integral of 1 over cos square. Theta d theta. Can? 1 over cosine square. Please don't use double angle identity here. Just realize that 1 over, when the numerator is just a normal 1. Please take note. When the numerator is just a 1, you don't need to resort to many different tricks. You just need to know a special identity. 1 over cosine is secant. So 1 over cos square is just secant square. Yeah? Trigo identity. Yes. From secondary school topic. The purpose of learning trigonometric identities and teaching it in A Max is so that you can do integrals over here in A levels. So if you forgot, good luck. Yeah, so 1 over, must recap. You got more things to do to catch up on. So 1 over cosine square is secant square. Then after that, you integrate secant square. You need to remember, differentiate tangent, you get secant square. Of course, it's available in MF26. So you get back to tangent theta. And are we done?
No.
No, why? Because remember the original question is in terms of?
X.
So what do we need to do now? Convert the theta world back into the X world, exactly. So how do we do that? We got X equals A sine theta, but here is tangent theta, then how? How do you link them?
Like sine X over cosine X.
Then how do you find cosine X or cosine theta in this case? You got X equals A sine theta. How do you get cosine theta? So that you can take sine over cosine. You didn't watch the video, is it? I gave you a list of videos to watch.
I did. Maybe I don't remember.
Triangle.
Oh.
Remember triangle?
Yeah. The
X equals A sine theta, you need to draw triangle. Okay, I review answer already. Okay, over here, they didn't show the explanation. Wow, the solution very bad. Okay, I need to give more elaboration. So what we have is X equals A sine theta. There's a simpler way. You don't even need to use the tangent theta equals sine theta over cosine theta once you draw triangle. Let me just copy it down. Previously, we got integral of blah, 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 dx equals to, we get 1 over A square tangent theta plus C. And then over here, we know that theta equals to, X equals A sine theta. How in the world did they go from this into this? Let me show you. First, you need to start with this guy, X equals to A sine theta. Then you realize that, I got sine theta. That just means I need a right angled triangle. So X over A equals to sine theta. Clear?
Yeah.
Then that means I can draw a right angled triangle, 90 degrees here, theta there. X, sine theta is what again?
The so.
So opposite over hypotenuse. So in this case, you see a X, you see a A, opposite over hypotenuse. So straight away you can write down X here, A here. Can? So what's the adjacent length? Pythagoras theorem. What would it be? Square root.
The square root of A square minus X squared.
Well done. Good. So now can you tell me what is tangent of theta? Remember, we wanted to replace tangent of theta here, so we need to figure out what's tangent theta. So which one?
The X over square root of A square minus X square.
Yes, correct. Then that's how they got this.
But how I don't need to use this?
It's a common trick. It's a common trick in substitution. Always. Must remember. I didn't know this. Okay, When you go into a theta world, you will stay as a theta. But when it's an indefinite you see, sorry, maybe I slow down a bit. I show you part E first. Part E, you did substitution with definite integral. You eventually went from the x world into the theta world. You got this as your final answer. Here, you could have also replaced the sine 2 theta over 2 plus theta back with an expression in terms of x, and then you substitute in the limits x equals 0 and x equals 3. Let me show you what I mean. So if x equals to 3 sine theta, our final answer for integral of, let's say without the limits, 9 minus x squared dx, we got 9 over, okay, I need to put the limits, 0 to 3. We got a 9 over 2 bracket sine 2 theta over 2 plus theta with limits 0 pi by 2. Now, technically, you could also replace the sine 2 theta back with something in terms of x. So maybe, but that requires identities, trigo identities, which is more annoying and unnecessary when it's a definite integral. Sine 2 theta is actually 2 sine theta cos theta, right? So that means sine 2 theta over 2 will be 2 sine theta over times cosine theta divided by 2. 2 cancel off, sine theta multiply cosine theta. Clear?
Yes.
But x equals to 3 sine theta. So that means that I can have a triangle here, theta here. What can I conclude? Let's say I have x, y, and z. Can you tell me what's the value of x, y, z? X will be what? Y will be what? Z will be what?
The
Okay, wait, I don't use x, y, and z. I use a different letter. Let's say A, B, C.
like sine theta,
Yes.
or sine theta will be the b over c.
Correct. In this case, if you make sine theta the subject, x equals 3 sine theta. So make sine theta the subject, 3 bring over. What do you get?
Like x over 3.
But you also told me it's b over c. So you can arbitrarily assign b with x, c with 3.
Oh,
Can you understand?
yeah.
You sound a bit confused. Anything confusing? Here, what I'm doing is I'm making sine theta the subject equals to x over 3. Then so means opposite over hypotenuse. So O over H. So x over 3. X over 3. Then what's A, the bottom one?
The adjacent.
Yes, but in terms of 3 and x?
Oh, the 3 square minus x square.
Minus, yes, good. Pythagoras theorem. Then, so now that we know this triangle, we can replace the sine theta and cosine theta already. Sine theta actually don't need, we already know it's x over 3, so equals x over 3. Then multiply by cosine theta, in this case will be square root 3 square minus x square over 3. So that is the sine 2 theta over 2 part. Then plus theta here. Okay, so what I'm doing is I converted this guy into this expression in terms of x. And then there's a theta here. I can also sub in with an expression in terms of x, which is the sine inverse of x over 3. So here you could also convert it. This will be equal to 9 over 2 multiplied by sine 2 theta over 2 would be whatever we just found out, x over 3 multiplied by square root 3 square minus x square, which is 9 minus x square actually, like over 3. Then you add on theta. In this case, it's sine inverse x over 3. So you realize immediately that it gets a lot more complicated in terms of x. Oh, I can also convert from a theta world back into the x world. Then you are asking me why I need to draw triangle, right? It's because you want to convert from theta world into x world.
Okay.
Then after that, since you are back in the x world, you can actually put in the limits 0 and 3. X equals 3, x equals 0. You will still get the same answer. You will still get the same answer of 9 pi over 4. Okay. But this is, let me show you why you can get 9 pi over 4. But this is actually not necessary. You can just do the following. I'll bring into the theta world already, then sub in with the limits in terms of theta. The alternative approach is to sub in the theta back into something in terms of x, then you can use back the original limits. This is not recommended. The method in the solution is recommended. Simpler.
Because it's already definite integral.
Yes, correct. But okay, later then I show you how do you get this into 9 pi over 4. But the main point here is that that's for definite integral, you no longer need to bring the theta back into x. Don't need.
Mm.
But for the indefinite integral, you have no choice. You must bring it back into the x world. Leaving it as tangent theta is not allowed. Here is dx, you need to keep as x. So the theta there is just to help you. This is just to help you.
Mm.
Then you need to bring it back from the theta world into the x world. And what do you need to do that? What do you need to do to make sure you can do that? You need to draw the triangle, the right angle triangle. From the substitution, x equal a sine theta, you can derive the triangle. Okay. A more painful way of figuring out what is tangent of theta. Maybe you are saying what tangent theta equals to sine theta over cosine theta.
Yeah.
You can also, but very slow. Just use the triangle is the most efficient way. But we already know sine theta, right? It's just x over a. Then how about cosine theta? Here's a suggestion. We already know sine square theta plus cosine square theta equals to 1, right? So how about if I make cosine theta the subject? Isn't that just plus minus square root 1 minus sine square?
Yeah.
And plus minus, how do you know which one to select? Over here, we know. Actually, over here, we might not know which one to select. So I will arbitrarily pick the positive one, okay? Just to keep things simple.
Mm.
Assuming that we can figure out a reason why we should reject negative. So far, we haven't found a reason. So this is incomplete. And this is not a very good technique. Then we can have what? Square root 1 minus sine square. But what is sine? Sine is x over a, right? Right, over here, sine is x over a.
Yeah.
Then you can replace with x over a, bracket square, which is square root of 1 minus x square over a square.
Mm.
Right, then you can factor out a square for all of them. So what I mean is, for example, take out 1 over a square. Isn't it just a square minus x square?
Yeah.
But with a square root.
Mm.
Then now you can simplify. So this is really just square root of a square minus x square as a numerator over a square. Simplify a bit more. Square root numerator divide by square root denominator. Square root a square is just modulus of a. Let's assume that a is positive to keep things simple. But how do I know for sure that it is? Okay, in this case, you can just assume it is. Then you can get back to square root a square minus x square over a. That's cosine. So now you can substitute this cosine back inside this question mark. Right, that's what you were suggesting, right? Tangent theta equals sine over cosine. You got sine already, you sub in, then you got cosine now using a super long-winded method and sub in. So do you think this method is recommended?
No.
No, please, draw triangle. It's your fastest way.
Okay.
Then you can sub in square root a square minus x square over a, and then you simplify. So keep, change, and flip. Remember when you divide fraction. So fraction divide by another fraction, keep the first one, then divide by the denominator, this entire fraction. So you have to flip it, multiply by the flip version. What happens to your a? Cancel off. Then you're left with x over square root a square minus x square. Yes, you can use this method, what you suggested. Yes, it will work. But that's assuming your algebra is super strong and you have a lot of time. And you remember that there's this identity you can use. If not, it's not recommended. No, horrible way. Do not do this. Very slow. Do triangle instead, okay? When you bring from x world back to theta world, must use triangle. Okay, Ken, moving on. So integration by parts. Wow, I talked too much already. Need to go faster. Okay. Part A is fine. Sorry, this one is cancelled off. Part A here is fine. Part B here is not fine. Something went wrong. Over here, it shouldn't be a x at the denominator times x power 3 over 2. I think your algebra got a mistake. X power 1 here, x power 3 over 2. If you bring the x power 1 on top, it becomes minus 1, right? So 3 over 2 minus 1. It's actually positive 1/2. Correct or not? But over here, you left out a 1/2. You see that? Then that's a mistake. Then error carry forward, everything else wrong. But up to here, if you calculated correctly and you wrote down a 1/2, then it will be correct. Clear? Algebra, careless mistake. Okay, part B. I circled the wrong ones. Okay, moving on. Not gonna go through that. Then part C. Wow, what happened here? Oh, you forgot. when you see how you pick u to be tangent inverse x square, right? When you
Yeah.
differentiate tangent inverse, you get 1 over 1 plus whatever square. Good, you managed to do that. X square is x power 4. But here, x square itself is a function. So you need to, it's a composite function. So you need to use chain rule. You need to differentiate the x square to get a 2x on the numerator. Right. 1 over is not enough. You still need to multiply by the 2x, which means you can bring the 2x on top onto the numerator. So your differentiation is wrong. Are you clear on that? Like in general, dy by dx is equal to dy by du, then times du by dx. You need the chain rule. Chain rule tells you need to differentiate the inside as well.
Okay.
Right? This one is just chain rule in general notation form. I don't think it's useful to you. You just need to know how to differentiate. Inside, you see, it's not just a x, it's a x square. So you need to differentiate x square to get your 2x. Okay, so that's why error carry forward everything else wrong. Here should be a 2x over. If your numerator is a 1. So let me just go through this one for part C. It's a bit more involved. So for part C, integral of x times tangent inverse x square, you pick x u equal tangent inverse is correct, dv by dx equal to x. Just remember the rule. This one is just a rule of thumb. It doesn't always work. But you need a method to pick your u and dv. So in this case, what you notice is that tangent inverse is inverse trigonometrical. Then x is algebraic. So A is on the right, I is on the left. That means you have to pick I to be the one you differentiate, A to be the one you integrate. Oh. Yeah. So maybe I highlighted I and A maybe in different colors. Then this guy is your I. You try to integrate the tangent, you try to differentiate the tangent inverse. And you try to integrate the algebraic. The X here, you try to, sorry. The X here, you try to integrate. Okay? Yeah, just use table method. Then just remember, integral of u dv is equals to uv minus integral v du. Okay? So in other words, this pair minus away integral of that pair. So this pair is referring to this pair. Then minus sign integral followed by a v du. What is v du? It's this pair here. Can you see? Purple minus integral of pink color. This diagonal minus integral of that guy. Or you can remember Kimsdi, K-I-M-S-D-I. But you need to swap around. D is here, I is there. Just remember the formula. So let's do that. In this case, you get uv, which is x squared over 2 times tangent inverse x squared. But with the limits, remember, 0 and 1, you need to sub in limits already, 0, 1. Then, did you do that? Let me see. You didn't, you see? Another mistake. You never put down the 0, 1. That's another mistake. Can you quickly do a correction for this one? Yeah, make sure you remember, after you get the first part, uv already, you must sub in the limits 0, 1. Okay, draw a vertical line, then put 0, 1. Okay, go back to the solution. Then after that, you minus away integral, still have the limits, but you have the pink color, x squared over 2 multiplied by 2x over 1 plus x power 4. So let's see how we can deal with this integral. Maybe for the upper limit one, do you understand how you got a half pi over 4? Is this part clear?
Like
sub in x equal to 1, sub in x equal to 0, then minus. Okay, I write it out. So what we have will be 1 square over 2 times tangent inverse of 1 minus away 0 square over 2 times tangent inverse of 0. This part clear to you?
Yes.
But tangent inverse of 1 is actually what? Pi over 4, exact value, please remember.
Okay.
Or you can use calculator. Calculator won't work. They cannot give you exact value of pi. No choice. Must remember the table. Remember the exact 30, 45 degree, 60 degree triangle? The table?
Yeah.
Can I sine, cosine, tangent? I leave that to you. This one, secondary school A-Max must remember. I don't go through again. If not, I'm repeating. Waste time. Okay, tangent inverse is pi over 4. Then 1 square over 2 is just half. Oh, it's just a half. Then minus away 0 square. That's just a 0. Then 0 divided by 2 is? 0 divided by 2 is? 0. Multiplied by tangent inverse 0 is still a 0. 0 times 0 is? 0. So you're just left with half times pi over 4. Okay?
Okay.
Okay, that's how you evaluate this guy. Then after that, integral of x squared over 2 times 2x over 1 plus x power 4. 2 and 2 can cancel off. X squared times x is x cubed. So here you get x cubed already, but they purposely multiply and divide by 4. Right? You know this trick, huh?
Yeah.
You know why they do it? It's because of this guy over here. Differentiate x power 4, what do you get?
3x power 3.
Huh? 3x power 3?
4x power 3.
4x power 3, okay. But in other words, 1 plus x power 4, if you differentiate the entire thing, you get the numerator, right?
Yeah.
Because differentiate the 1, you get a 0, so it doesn't affect. So that means what we have now is the integral of f prime x on top divided by fx below. I think you remember this identity, it should be just ln modulus. Yeah, okay, good. Then don't forget the 1/4 in front. 1/4 in front, then you get the ln. Now you need to sub in and the minus in front. Then now you need to draw square bracket. Then you put in the upper and lower limit 1, 0. So notice that we did not use we are in integration by parts. We are not doing substitution, so you don't need to change from x world to theta world, x world to u world, or anything like that. X remains as x. Now you just have to sub in now. So sub in x equal to 1, you get 1 plus 1 power 4, which is 2. ln of modulus of 2. Modulus 2. 2 is already positive, so you can just drop the modulus, so it's ln just 2. Then you sub in x equal to 0, you get ln 1. Maybe this one I should calculate for you. 1/4 ln modulus 1 plus 1 power 4 minus 1/4 ln 1 plus 0 power 4. I hope you realize that you can actually factor out the 1/4. So you didn't actually have to write down, you have to calculate the 1/4. Notice that? You can factor out the 1/4.
Yeah.
Let's evaluate the ln then. So this one is 1 plus 1, which is 2. So ln of modulus of 2, which is just 2, minus away ln of 1. How come don't have ln of 1 here?
Is
What's
0.
ln? Very good, exactly. How does the ln graph look? Please remember, asymptote at x equal to 0, and then you just go upwards like this. Pass through 1, 0. This is y equal ln x. When x equals 1, you get 0. So this is 0. That means you are just left with ln2 multiplied by 1/4. That's why you have this over here. ln2 times 1/4. Is it clear?
Yeah.
Don't forget the minus sign, Okay, good. That's how you get the answer. Moving on. Let's see your answer for part D. Part D is correct. Good. You forgot the x here. Forgot the x. Careless mistake. Tangent x dx. Don't forget. Part E is fine. Part F, you forgot a dx over here. Right. So far you've been doing it. You see dx. Then you see dx. Then suddenly you got lazy. You forgot the dx.
Yeah.
Forgot. Bad. Must remember. Okay, Ken. So part F, what happened? You okay? Good. You use integration by parts. This part I assume it's irrelevant.
Yeah.
Yeah. You should scratch it off. If it's not relevant. Okay. Yeah, just focusing on this one. Yeah. So what you have done is you chose u to be e power x and dv by dx to be 2 cos. To be 2 cos 2x. Bad choice. Bad choice. Remember LIAT?
Yeah.
Who do you differentiate?
The L.
Differentiate. Then the other guy is integrate, right? This direction should be differentiate. That direction will be integrate. Closer to the left, you differentiate. Closer to the right, you integrate. So you got exponential here, and you got trigonometric. This part clear to you? How to identify the types of functions?
Yeah.
So exponential is what? Let me just highlight. Like maybe I'll use light blue. This is e power x. It's under here, right? E. Then you got cosine 2x. That's trigonometric. It's on the left. So who should you be differentiating? Who should you be integrating?
Integrate E.
Integrate E, right? But here you pick U to be E. That means the next step you have to du by dx. You differentiate the E. Wrong already. You see that? You're supposed to integrate, but over here you differentiated the E. Do you see that?
Yeah.
Then over here, like cosine from dv, you go to v. That means you're integrating. Integrating the trigo. Wrong direction already. You see that? So you never use the Layet rule properly. Now, actually, the Layet rule, it's just a rule of thumb. Rule of thumb means it doesn't always work. The purpose of integration by parts is always to make sure that once you get the uv minus integral v du, You want the integral VDU to be simpler. Then this rule of thumb, LIAT, is to help you to speed up your guess and check. Essentially, integration by parts is just a guess and check game where you pick the correct u and dv by dx such that the integral over here, when you eventually break it down into minus integral vdu, becomes simpler to integrate. However, here you pick a wrong choice. Oh, bad choice. Should have swapped it around. You eventually get to this bunch of nonsense that will cancel each other off. Then you'll get 0 equals to 0. Yes, this is true. Your algebra is fine, but you made a wrong choice. Okay. Let me show you. This is a very interesting question that involves integral. You eventually get this guy over here supposed to be the same as the previous guy. Then you have to bring over. I think you know this trick. That's why you wrote down a 2 here.
Yeah.
Right. Minus bring over become plus, but you made a wrong choice over here. That's why you couldn't solve it. Okay, moving on. I also gave you some comments over here on the correct choice. Let's just look at the solution in detail. So for part F, you integrate x squared cos x. What you should do is to pick u equal x squared and dv by dx equal to cos x. Wait, actually wrong section. Oh, we already moved on. Sorry. Is it this one? Sorry, let me just double check. Oh, your first choice was actually correct. Sorry, this is actually relevant. Oh my goodness, sorry, wrong question. This part is relevant. It's for the first integral. Right?
Yeah.
Then after that, you're focusing on this blue color highlight. Then you're trying to integrate this. Then you make a wrong choice here. Okay. So your first step is fine. Good, let's just look at the solution. So you did the same first step. It's perfect. You eventually get your e power x times sine 2x minus integral 2e power x times cosine 2x. This part okay?
Yeah.
Yes, can. Then now we want to leave this alone, so you copy and paste it. Maybe I highlight it. Leave this alone. Then here you got a minus 2. You just factor it out. Then now you want to focus on integral of e power x to the power times cosine 2x dx. So maybe I should change the color a little bit. Or maybe I'll use green for e power x and light blue for cosine 2x. So over here, what you should have done is to pick u to be cos 2x and dv by dx to be e power x. Okay. Also, your notation a bit funny. You write down like a u on the top floating above, and then you write down cosine 2x like this. Not very correct. Should put an equal sign. Just put it along the same line. Just put an equal sign. That's just a minor thing. Then e power x is the dv by dx. The cosine 2x is your u. Then you just have to differentiate, integrate. Differentiate cosine, you get negative 2 sine 2x. Why do you have the 2 here? Chain rule. Remember?
Yeah.
Yes. Then integrate e power x. Very easy. Get back the same thing. E power x again. Then now you can just take this guy minus that guy. This guy minus that guy. So it will be this guy, and you minus away that guy. Is it clear to you how I got this?
Yeah.
Can I highlight it? Brown color minus light green. Minus integral dx of light green. Product of du by dx with vdu by dx. Okay, Ken, then that's how you get this. Then you have to bring the negative 2 back in. The purple color must multiply in. So negative 2 multiplied by e power x times cosine 2x is negative 2ex cos 2x. Then negative 2 multiplied by a negative integral. Negative become a positive. But then there's an extra third negative sign here. Can see? 1, 2, 3. That's why you end up with a negative here. Okay? Then after that, 2 times 2 is a 4. Don't forget the rest, e power x times sine 2x. At this stage, you should realize, over here, e power x sine 2x, also the same as the original. You see that?
Yeah.
So over here, you must always have a minus sign. This minus sign over here is extremely important. Must be a minus. If you don't get a minus, you're gone. When you got exponential multiplied by a trigo integral, it will always be this pattern one. There will be a minus some scalar multiple of an integral of the same thing as what you had on the left hand side. So in other words, this guy, you can factor out the 4, right? So what you end up with is just this entire expression, copy and paste, but you got a minus 4. bring over becomes a plus 4.
Mm.
Plus 4 times of the integral. So that means that here got one copy, but you add on 4 of them. That means you'll get 5 times of these. 5 times of what? 5 times of this part over here. Is that clear?
Yeah.
Can up to this stage?
Okay.
Then now that you have 5 times of the original answer, you just have to divide over. So it's 1/5. What they did here is they did something funny. They factor out the e power x first. Okay, maybe I rewrite it. E power x multiplied by sine 2x minus 2 cos 2x. Then after that, you divide by 5, which is what you get over here. Don't forget a plus c. Can? Okay, can. You should try the question again. All those that you got wrong, must redo. Redo until you get it right. Let me know if you got any questions. Oh. Okay, can. Part F done. Part G, what happened? Oh no, this one. You see, there's a cos x square here. I show you the question. It's this is finally the part that I was talking about. Cos x square here is not the same as cosine x then square. It is not equal to cos x square. There's an invisible pair of brackets here. Here we cannot integrate cos x square. So what we need to do is to be smart about it. We have to instead pick you cannot pick x cubed and then cos x square. No, you have to reduce it to you have to change it into x square multiplied by x cos x square. Think of it as this instead. X square on the left and x cos x square on the right. Why? Because here, x square, if you pick as the algebraic, write down again, LIAT. So which one do you differentiate? Which one do you integrate? Left side should be DI.
The differentiate.
Differentiate. Then right side should be
Integrate.
integrate. Okay, good. Then you got algebraic and this one is trigo. Actually, it's a mixture. This here is a very special one. It's a mixture of algebraic and trigo. Oh, so that's when your LIAT rule doesn't really work anymore. Algebraic here and trigo there. But here, close enough. If you see the A and the T, you still think that algebraic should be differentiated, T should be integrated. So that's why we pick x square and x cos x square. Why do we pick x cos x square? Because it can be integrated. Chain rule. Do you realize that if you try to differentiate x square, you get 2x?
Yeah.
Like for example, if you let fx equals to cosine x square, f prime x is actually just 2x times cos x square. So what does that mean? If you try, what does that mean? It means that if you try to integrate 2x cos x square dx, isn't that just working backwards? This is the derivative, right? You integrate will work backwards. So you get back the original expression. This is just cosine x square. Agree?
Yes.
But now here we pick 1x. So that means we need to account for that 1 by dividing by 2. You see that? You just have to bring this 2 over. Then you get your integral of x cos x square dx equals to 1/2 of cos x square. Oh, sorry. Did I say cosine? I meant sine. Sorry. Differentiates cosine is negative sign actually. Let me think of it. Negative here. Why is it off by a negative sign? Let me double check out. Oh, sorry. I should do it the other way around. Sorry, can I just edit this a bit?
Yeah, sure.
Sorry, this should be a sign. You should start with a sign. Then you differentiate, you get cosine. And then you don't need a minus sign. Is this part okay to you?
Yeah.
Can I differentiate sine, get cosine? Then chain rule, differentiate x squared, you get 2x. Then after that, you have a cosine in front over here. So you get 2x times cosine x squared. Here it should also be a cosine. Sorry for so many edits. 不对不对. Oh no, sorry. Let me change it. It should be a sign here. Sorry. So many edits. Basically working backwards. Okay, integrate 2x cos x squared, you get back to sine x squared. Integrate 2x cos x squared, get back to sine x squared. Can? Then you can bring the 2 over, so you get a 1/2. Okay. That's how you get a half sine x squared here. Okay, then after that, you just need to differentiate x squared, you get 2x. Then you just take uv minus v du, integral of v du. So that's what they did over here. They got your uv minus away integral of v du. Is this part clear to you so far? Okay, good. Then after that, half x squared sine x squared, you could just leave it alone first. Then now you try to evaluate negative integral of x sine x squared. How do we do that? It's just half cos x squared. Do you know why? Minus become plus. Well, it's very simple. Take this, you differentiate, you get negative x sine x squared. The rule here we're using is integral of f prime x times the g of f of x dx is equals to, yeah, you just integrate, right? You just get back to g of f of, capital G of f of x.
Yeah. Okay.
Right? Yeah, it's just chain rule basically. Here, if you try to differentiate half cos x squared, you will get back to negative x sine x squared. Okay? Integration work backwards. So that's how you get half cos x squared. And plus c. Okay, can we have a short 5-minute break? Before we continue. Okay, then for question 9, right, what you need to realize is that you did something wrong with the algebra. I'll just zoom out and leave the page over here and let you see. Okay, short break. Come back in 5. Mic test, mic test.
Yeah, can hear.
Okay. Let me just see if I can resume share. Okay. Let me try again now. The screen share. My screen share stopped working. Hold on a second.
Okay.
Sure. Okay, Ken, back. All right, so have you figured out how to solve this question?
Must use the eh yeah, must use the special the given formula.
Yeah, you can do that. Or use the modified version. Here, yeah, I don't really like that formula because there's the 1/a here, which is a bit funny. Yeah. Oh, I don't really like the formula in the standard formula, but here in this case, yes, you can do that. You can use the formula. Oh, why can we use the formula? Let's take a look. Here, when you integrate this 1/4 minus x squared, I go through the solution first before I look at your version of the solution. Okay. 1/4 minus x squared is actually the same as what? Integral of 0 to 1 of 1/2 square minus x squared dx. So it's a square minus x squared. Then if you look at the MF26, 1/a square minus x squared is actually just 1/2a. Right, there's actually an extra 2 here, which is quite weird. Here they tell you the condition. You can only use it when the modulus of x is less than a. So let's check if this is true or not. Modulus of x is less than a. Modulus of x is less than a. In this case, a is 2. Is this true? How do you check? What is x? X is actually referring to the limits over here, 0 and 1. Right? X equals 0 to x equal to 1.
Yeah.
Is it true?
Yes.
0 to 1 is modulus less than 2? Yes, it's true. Therefore, we can use it. If it's not within, if it doesn't obey this less than 2, can
Then
we use the formula?
cannot use.
Cannot. So what should we do instead?
Mm,
1 over a square minus b square. Isn't that just a minus b times a plus b?
yeah, can use the partial fractions.
Yes, use partial fractions. Okay, but partial fraction will always work. Can this one formula, you need to check this rule first, which is a bit more troublesome to me personally. But anyways, using the formula works, you will get this answer, but you have to sub in the limit 1 and 0. Subbing in, you'll get 1/4 ln 3. Is that clear? How you get 1/4 ln 3? Can I?
Yeah.
You get 1 plus 2 over 1 minus 2, which is 1 over -1, modulus, which is -1. So modulus of -1 is just +1, so ln of 1, which is just a 0. 1/4 times 0, you get a 0 in front. Then minus away this 1/4 ln 3. Actually, here, let me double check why it's a 3 first. Okay, I'll just calculate it. 1/4 of ln of 1 plus 2, which is 3. Oh, it's a 3, right? 1 plus 2 is 3. Then 1 minus 2 is -1. Take the modulus. Minus away ln of 0 plus 2, which is 2, over 0 minus 2, which is -2. That's 1/4 of ln 3, bracket, minus away ln 1, bracket. That's a 0. That's how you get a 1/4 ln 3. But for the right-hand side over here, 1 over square root of the 1 minus p square x square. P square x square is actually just what? It's actually just bracket px then square, right?
Yeah.
Yes. Then in this case, if you try to integrate, you get a sine inverse, but the inside is a px now, right?
Yeah.
But you have to divide by p. Why? Because of chain rule. If there's a p here, you have to divide by p. Can? Can now? Okay. Then after that, you have to sub in the limits. Upper limit 1 over 2p, lower limit 0. Then you sub in. Here, let me show you how to do it. On the right hand side, you got 1 over p, but then the sine inverse whatever is substituted with the upper and lower limit. So we get sine inverse of something minus sine inverse of another thing. Can you tell me what's the first one?
The px.
But x gets replaced with? Mike Tess, can you hear me?
Yeah.
Oh, you're thinking, sorry.
Oh, but
Upper limit, right? Upper then lower. Upper minus lower. So you sub in the x with?
1 over 2p.
Good. Then the other one? P times x, but this case the the x is now a 0. Clear?
Yeah.
Good. Then 1 over p bracket sine inverse of p times 1 over 2p. That's p over 1, by the way. If you need that. So what do you get?
Like pi is 0.
Here the p and p cancel off to give you a half. So it's just tell me the simplified version for step by step. Sine inverse of a half.
Sine inverse of half.
Then minus sine inverse of a 0. Can? What's sine inverse of half? Or sine theta equals half. What is theta? Don't know.
Is it the special?
Yes. Oh no. Oh no. Must remember sine theta 30 degrees, 45 degrees, 60 degrees, also known as pi by 6, pi by 4, pi by 3. Over 2, over 2, over 2.
Oh, so it's pi over
Square root, square root. 2, 3. Yes, it is pi over 6. Okay, pi over 6. Then sine inverse of 0 is just 0. So pi over 6 minus 0 is just pi over 6. That's how you get 1 over p times pi over 6. Clear? Right hand side?
Yeah.
Good. How about the left hand side? Okay, still whatever we calculated just now. Then you just make p the subject. Okay, I show you how to do it. So here you got divide by p, so bring it over, become times p. So what we will get? P over 4 ln 3. Right, because you multiply by p, 1 times p is p. Equals to pi over 6. Then there is you can rewrite as p times ln 3 over 4 equals pi over 6. So if you make p the subject, you just need to bring this over. So it becomes 4 over ln 3. Pi over 6 times 4 over ln 3. 4 over 6 is just 2 over 3, right? I can cancel off a common factor of 2. So I'll be left with 2 pi over 3 ln 3. That's how you get the answer. Okay, all you have to do is calculate the left side, calculate the right side, make p the subject. And you need to know how to sub in the x. You need to know it's a px first. Then you need to know how to substitute in your x, upper and lower limit. Okay? Okay, let's see what went wrong with your working. You got ln 3 over 4 is fine. But here, you wrote down wrongly. Do you see? You missed out on a p. This is question 9, by the way. Missing p.
Oh.
Ah.
Wonder I cannot find the answer.
Yes, correct. And also, let me see what was the other thing. The other thing is that you did something a little bit funny. You factor out a p square. So at first we already got a very nice 1 here already, but you factor out a p square. So you get 1 over p square minus x square. Then you get 1 over p square minus x square like this. That's okay. But then let me just double check the formula from the MF26. Okay, so you have a to be 1 over p, right? Then replace the x with 1 over the a with 1 over p. That's actually fine. So you get x over 1 over p here. Then that becomes a px, right? Yeah, so it's still okay. So it's still a px. But yeah, I think you just missed out on that. Instead of writing 1 over 2p, you wrote down 1 over 2. That's a mistake.
Okay.
Okay, yeah, then the rest is fine. If eventually you get the two expressions, you should equate them. But you realize that, how come here don't have p anymore? Then that's the problem. You forgot the p over here. Okay, moving on to question 10. Let's see your mistake first. Here you got up to this step. Good, you managed to calculate 1 over integral of 1 over 1 plus x squared is just tangent inverse. Then you sub in upper and lower limit. That's good, with a minus in between. Then in this case, you equate it to the 0.22. At this stage, this question actually just requires you to use a GC. You can type this in and you get the answer.
Huh?
Can. Okay, wait, I show you. Hold on a second. Okay, let me just share screen to my calculator. You can see the calculator?
Okay.
Okay, so all that you need to do, right, actually is type in tangent inverse. So second tangent inverse, what is it? There's an a square. Just pretend a is the variable, so x squared. Then you minus away tangent inverse of x. That's the first equation. Then the second equation is 0.22. Then you just need to graph. Okay, maybe I zoom in. I think I can see the intersection already. Somewhere here. Well, the quality of my graph is quite bad. So I probably need to improve it. Oh, it's on the right side. Okay, maybe I need to move a bit more to the right. My X max, maybe I change it to 2.2, 2.5. Yeah, then I can see the intersection somewhere there. So second, calculate number 5 for intersect. Start from the left side. You see the first intersection? Negative 0.1071346. Or 187, sorry. Yeah, so that's your first answer. Then the second answer. Oh, hold on a second. Let me double check. Something is not right. Sorry. Let me read the question again.
Okay.
Plus x squared. Integral from plus x squared is tangent plus. Yes. Okay, y equals 0.22. I got the wrong answer. I should be getting 2.04 and 2.62. Something is wrong with my graph. Let me double check. That's weird. 1/1 plus x squared. When you differentiate tangent inverse, you get 1/1 plus x squared, definitely. But why is it wrong? Sorry. Give me some time to think about this. It should work. Why is it not working? I use Zoom standard. Okay, in this case, right. Okay, I get it already. I got negative solution for my A here, which is not what I want because if you look at second, calculate, let's say, the intersection. Are you with me?
Yeah.
Can I? The intersection is negative 0.187, but negative 0.187, but that's not what we want. The question asks for positive values of A, right? So that means that I actually need to zoom out. I need to restrict my x values to be positive. So let's say I go all the way to 5. And I graph. Then I graph it. Then I need to find the positive solution. It's actually there and there. Maybe I should change my scale down a bit. Maybe, okay, I already know roughly what would be the value. So maybe it would be 0.5. Somewhere here, right? Can you see?
Yeah.
So I need to zoom in. I'll just use zoom box. So it will take some time to load. Just gotta wait. Is it a bad idea to wait? A bit slow, So maybe I'll just press enter, you can pause it. Press enter, you can pause it. Then you press enter again, it will continue. If you want to stop it, right, you can press on to terminate it. But since it's already graphing, I'll just let it continue. Okay, eventually we get those two intersections. I don't think we should increase the quality anymore. Just straight away find the intersection. So second, calculate. Go to number 5 for intersect. Enter. Maybe start from the left solution. There's actually 2 solutions. Enter. You get the first one, 2.0416. Can see? Can?
Okay.
Then the second one, do the same thing, but move a bit more to the right. So I'll move a bit more to the right. Enter, enter, enter. Then I get the second solution, 2.617. Can?
Can.
Yeah, then those are your two solutions already. Okay, change back to my iPad. Yeah, so here the question is even lazier. The solution is even lazier. They say by plotting the graph of y equals to this guy. So you don't even need to calculate. You don't even need to check the MF26 to know that 1 over 1 plus x squared integrate is tangent inverse. Then they just replace with x squared and x instead of a squared and a. As well as y equals 0.22 on the GC. Then they get the two solutions rounded off to 3SF. Okay? That's all. That's all. Let's use GC only. Yeah, this question.
Looks funny.
Yeah. Yes. So here, problem is you cannot take away the tangent from both sides like this. This is wrong. You cannot factor out tangent inverse. Factor tangent inverse and sine inverse and cosine inverse as well. They are not that simple. Cannot just factor out. Okay, so this is wrong. The rest of the working here is wrong. Okay, no algebraic method to solve. Must use GC. I don't know how to solve this actually. I probably need to use a special identity involving tangent inverse, which is quite complicated and not required by the question. Just use GC. Okay, moving on. 11 is correct. 12 is correct, but here actually I think what they meant for you to do is to do it step by step. This question is from 1999 before MF26. So yeah, that's why they actually wanted you to show the working. So over here, what you want to do is to realize that when you here when I differentiate ln of something, it's really just 1 over that something f of x, and then I differentiate the f of x, right? So it's like f prime x over f of x.
So it's zero.
Yes, correct. 1 over f of x is because of the ln, then f prime of x is because of chain rule. So here, just to save some space, I differentiated secant x plus tangent x to get my f prime x. I differentiated it and I got it to be secant x tangent x plus secant square on top. Okay, so let me explain this. Differentiating secant x, you get secant x tangent x. That's actually also from the MF26 because I was lazy. Okay, then differentiating tangent x, you get secant square x. Okay, you got this already. Good. Then you can just substitute in the f prime x numerator, divide by the denominator secant x plus tangent x. What you realize is that secant x appears 2 times. So you can factor out a common factor of secant x. You end up with secant x open bracket tangent x plus secant x. Clear? Then what happens? There's a factor of tangent x plus secant x at the numerator. There's a factor of secant x plus tangent x at the denominator. They are the same. So I can just cancel off common factor, blue color line. I'll be left with secant x. Okay? Yeah, so that's what they tell you to do in part 1. Then for part 2, integrating x sine. What is the question? Let me double check the question first. You are trying to. This is question 12. Where's your question 11 actually? Oh, your question 11 was incomplete. Right. Okay, I'll go back to it later. Question 11. Question 12. Okay, then after that, they ask you to find the integral of x sine x. Okay, you got the answer. That's fine. Good. Then part 3, something is wrong. Something went wrong. Let me double check. Okay, you first integrated this guy. X times sine. For part 3, you're trying to find the integral of x times sine x times ln of secant x plus tangent x dx from 0 to pi by 4. You also never put down the limits 0 pi by 4. So yeah, 0 and pi by 4 there. For this other guy, what did you do? Let me double check. You pick u to be ln of secant x plus tangent x. You pick dv by dx to be x sine x. Okay, you differentiated it. Then you get minus x cos x plus sine x. Hold on. Actually, why would this be correct? Let me see. Oh, you're using product rule. Okay, can. But here it's not very smart because this is a hence question, right? You see, the part 2 already hinted to you. Integral of x sine x dx. And you found the correct answer. So that means when you pick your u and your dv, wouldn't it be smarter if you let u be if you let hold on a second.
I got do that
Is this
too.
correct? Oh, you did that. Yeah, you integrated. Oh, sorry, I'm wrong. Let me read again. You're not using product rule. You are using integration by parts from part 2. Oh, right. Sorry. I misread your working. Oh, this is fine. You're using that. You're using it a part 2. Okay, can. Then that means that you end up with the u times v minus integral of v du. But over here, the second integral is not so good. Oh, this first integral is okay, but the second one is not so good. When you try to integrate the secant x multiplied by minus x cos x plus sine x, you chose u to be secant x dv by dx to be secant x again. Why? You chose the same thing 2 times. Cannot be, right? Must pick the entire expression.
Yeah, I write wrongly. I think it's supposed to be the
One of them is secant x, the other guy should be the minus x cos x plus sine x, right?
yeah.
Yeah, okay, I think it was a careless mistake. Okay, then in this case, I'll just look at the solution then. Here, actually, let me just double check the solution they gave. Oh, right. Over here, actually, this integral, right, it looks very similar to a certain answer. Oh, wait. Oh. Sorry. I understand already. Okay, this part here, actually, you can do some trigonometrical identities. Okay. Let's see how we can integrate this without using integration by parts so quickly. Okay, let's look at the solution now. 11, I'll come back to it. Part 3 over here, you managed to get to this part here. That's fine, correct. But here, minus x cos x, I highlighted minus x cos x plus sine x bracket times secant x. Actually, what is secant x? Secant x is 1 over cosine x, right? So you can actually multiply by 1 over cosine x over a pair of brackets with a plus sign. What do you get?
Negative x plus
Sine over tangent x, right? Sine x times 1 over cosine x is sine x over cosine, which is tangent. So now you got 2 separate terms. So all you need to do is actually to integrate this guy. Right or not? Is that easier?
Yeah.
Don't need to use integration by parts. This is a very tricky question. Okay, Ken. Then for the first part here, do you understand how you got this expression?
No.
Okay, you get the okay, every time you see square bracket pi by 4 and 0, what are you supposed to do?
Sub in.
Sub in which one? Sub in. Okay, can you tell me the entire procedure?
Like
what do you mean sub in?
The negative pi over 4 cosine pi over 4 plus sine pi over 4, then bracket secant pi over 4, then minus
plus tangent pi by 4, then minus away the same expression, but you replace the x with
0.
Okay, can you understand already? So in other words, this entire part here, you calculate as this part, but x equals pi by 4 and 0, and then you subtract. Yes? Okay, good. So do you need me to show you this part?
Don't need.
Don't need, okay, Ken. Let me know if you are struggling with this. Because you need exact values. Just need to take note that secant is 1 over cosine. 1 over cosine. Maybe I'll write it down to remind you. Yeah, so now this other part here is just the integral from 0 to pi by 4 of x minus tangent x. But here, how come just now I got minus x plus tangent x? Here is a x minus tangent x. What happened? What happened?
They changed the minus to plus.
Yes, the minus into plus. So they factor out a negative sign. They did an extra step. So here minus, if you factor out, it become a plus, plus factor out become a minus. That's how you get positive x and negative tangent x. Okay, anyways, so that's why you have a plus here, plus the integral of x minus tangent x. So you just integrate term by term. Integrate x, you get x squared over 2. Integrate tangent x, you get ln secant x. It's in the MM26. Differentiate ln, you can ln secant x, you get tangent x. Then after that, square bracket, you get 0 to pi by 4 with a plus because we changed to a plus already. Okay. Yeah, then now you just have to sub in x equals to pi over 4, sub in x equal to 0, then you subtract. Okay, maybe I'll show you for this one. I'll show you for this one because it's quite fast. So what you get is pi over 4 square over 2 minus ln of secant of pi over 4 minus away 0 square over 2 minus away ln of secant of 0. By the way, have you seen the secant graph before?
No.
Okay. Let me show you. Hold on a second. Let me share screen over here. This is secant x. Have you seen it before?
Yeah. No.
Secant x. Whoa. What is secant x? Secant is 1 over cosine. You should know how to draw 1 over cosine already because reciprocal function 1 over f of x we got teach in A level H2. Okay, this is cosine x, right? Can see or not?
Can.
Down, up. Down, up. So 1 over, so secant is really just 1 over cosine. So that means that every value that's small, when you take 1 over, it becomes 1 over small becomes big.
Yeah.
Yeah, then how about 1 over big? It becomes
like 10 to 0.
10 to 0, small. Okay, so over here, when it's 1, what happens when you take 1 over 1? X equals 0, 1, come on. You still get 1. But then as this y coordinate drops down from 1 to 0 0.8 to 0 0.7, eventually drop to 0, what happens to the corresponding reciprocal graph? 1 over cosine x. Would it decrease or increase?
Increase.
Increase. So that's why if you look at the secant x graph, it increases. You can see it now. Cosine goes down from 0 to pi over 2. So the secant will go up from 0 to pi over 2. But it goes up very fast. And it went out of the picture already. It just keeps going up. Then using that same argument, you can do it for the left half as well. I mean the left half from here to here. Can you see? As it goes downwards, the graph goes upwards. And eventually when it reaches a 0, pi over 2, 0, it becomes a particular asymptote. Right? Because you have 1 over 0. All right. Then likewise, for the other half, just that now we get reflected. The cosine graph is symmetric. So this part here is just a reflection about the x-axis. You just get the same happy face curve, this one, but then you reflect it. So now it becomes a sad face, like this. Can? Yeah, then that's why, then you just repeat for every other part of the cosine curve, and that's why you get this graph. Have you seen the cosecant graph? This is why you got a sin x. Have you seen the cosecant graph?
No.
Let me show you. You never explored before on your calculator. Okay.
No.
And, so 1 over sin x. It looks like this. It's almost the same as secant x. This is secant. That is 1 over sine, which is cosecant. Let me show you before, after. Okay, so basically it's just the same as the cosine graph. It's just each of the turning points you have a u that's touching it, like this. At each of these points. Okay, yeah, that's how the graph looks, just to let you know. You can also try for 1 over tangent x on your GC. In your own time. Okay, back to the question. Yeah, so what is secant of pi over 4? Secant of pi over 4 is just 1 over cosine pi over 4. So cosine pi over 4 is what? It's actually just 1 over square root 2 over 2. Yes? 45 degrees, which is 2 over square root 2. Okay, then you get ln of this guy. Then pi over 4 square is just pi square over 16. Divide by 2, you get pi square over 32 minus. Okay? Oh, by the way, 2 over square root 2. Isn't it just 2? Just 2, right?
Yeah.
Yes. Yes. Good. Then this case, how about 0 square over 2? It's just a 0. It's just a 0. How about secant of 0? 1 over cosine 0.
It's 1.
Yes, correct. It's a 1. Then ln of 1?
0.
0. So 0 minus 0, whole thing becomes a 0. Then minus 0, you can just throw it away. So you end up with pi square over 32 minus away ln of 2. That's how we get this guy over here. Okay, we were calculating this. Okay, that is for part 3. Moving on. Section 2. Okay, let's see what you did. This goes beyond what I assigned as homework, but okay, never mind. Just go through. Let's see what you did so far. Supplementary one. Oh wait, sorry, I need to go through question 11. Sorry, let me go back to question 11. Here, question 11, before we go supplementary, sorry. Look at question 11, differentiate e power x squared, you get 2x ex squared. That's correct. So what we know about differentiation, if you can, differentiation goes forward, but what about integration? Integration just brings you back because integration is the reverse of differentiation. So that means that if you integrate 2x ex squared, you just get back ex squared plus c. Right? Using this information, integrating something complicated, we get back an answer. That means that we can now use integration by parts and we can make use of this information. Would you want 2x ex squared to become your dv by dx or your u?
The dv dx.
Dv dx, so that you can integrate it easily, get back to your v. So because we already know the answer. So that's exactly what we should choose. dv by dx will be 2x ex squared. And then the front part here, you have no choice of to pick a x cube because of the question. Then that's what you did. You got the correct answer, uv minus vdu over here, and then you get to integral of this one, but you got stuck. But what you should realize is that 2x times ex squared, doesn't that look familiar?
Yes.
It's the same as the integral from before, right? The first integral. In fact, it's the same as this guy. When you pick dv by dx will be 2x ex squared, you integrate, then you get back ex squared. So you already know the answer. The integral of this guy is just e power x squared. E power x squared here. Right?
Yeah.
Then after that, you should know how to solve already. Now if you are able to integrate this, all you need to do now is to substitute in the upper limit. X equals square root ln 2, x equals 0. Then you just have to sub in the upper limit with ln 2, square root ln 2, sub in with 0, calculate it, and you eventually simplify back down to ln 2 minus half. Can? Can I leave this to you. Let me know if you got questions. Just sub in only. Sub x equal ln square root ln 2, sub x equal to 0, then subtract. I just factor out a half so that I don't have to write so many things. You can factor out the half. Yep. Okay, moving on. Supplementary 2. So here, I don't know what you're writing. You write down S, we're integrating tangent 3x dx. Then you give me ln modulus. I think you're writing secant, is it? You wrote down SE.
Yeah.
Secant 3x. Answer is still wrong, unfortunately. Let's take a look at the solution. Okay, so how we do it is when you integrate, wait, actually let me just double check. Secant, where do you get this ln of secant, modular secant?
That one, the tangent.
This one,
yeah.
Oh, right. Actually, you might be right. I might be wrong. Oh, right, that works. Sorry, I didn't see that. Okay, let me double check. Oh, sorry, help me correct that. This is correct. This is correct. Sorry. You are correct. Okay, this works. Sorry, this is correct. Your working is fine. Just need to put a C there.
Okay.
Good. Okay, but let's take a look at the solution they gave us. So what they did over here is instead of tangent 3x, right, evaluating it already, they replace it with sine over cosine, and then they purposely multiply and divide by -3. Okay, why did they do that? Because now they see that the numerator is f prime x, denominator is f of x. So you can do ln of the denominator, which is cosine 3x. Okay, ln modulus.
Oh, why they get different answer then they will accept both?
Yes, because let's take a look why it should be the same. When you have a negative in front of the ln, you can bring it back in, right? It's like a -1. You can bring it back in. Negative ln of x is really just -1 multiplied by ln of x. So you can bring it back in as a power. So ln x power -1, right? This applies even when there's a modulus. So now if you bring it back in, what do you get? You get 1/3 of ln of modulus of cosine 3x, bracket the entire thing, power -1 plus c. The reciprocal of cosine 3x means 1 over cosine 3x, which is
The
co. Secant x, secant 3x, sorry, which is exactly what you gave as your answer.
Oh.
So it's correct. Yes. Your answer is correct. Sorry, I was wrong. You're correct. Okay, can Okay, good. Let's take a look at your next question. 1B, correct. Okay, nothing to go through. Part C, what happened? You forgot a 2 here, divide by -2, that you have 2 at the denominator. Okay, but otherwise it's fine. Okay, otherwise it's fine. Part D is fine. Part E, you completed the square wrongly. Oh, look at this. Wow, very careless. You see, you had the quadratic denominator, x squared minus 6x plus 8. So you know you need to complete the square. So you divide by 2, and then you subtract the same thing but square plus 8. But over here, take a look. What is 6 over 2 is 3. 3 square is 9. So there's a minus sign here, so it's actually a -9. Then you plus 8. What's -9 plus 8?
-1.
It's -1, not -17. You get -9 minus 8, is it? Instead of plus 8.
Yeah.
So that's why wrong. Then error carry forward. Okay, otherwise you know how to solve this. Yes, you're using the formula. It's okay to use the formula. Okay, then don't go through in detail. Okay, just complete the square correctly. Just -9 plus 8 is -1, not -17. Okay, moving on. Part G, didn't try. Don't know how to continue. Okay, I go through the solution now. So for part G, let us take a look. We got x over square root x minus 1. So there are 3 different methods that they suggested. Okay, let's go through them one by one. So the first method, what they do is they do something very clever. They realize that, I can just, there's an x minus 1 here. It's just a single x on top. How about if I'm -1 plus 1? I can do that, right? It's still the same, equal.
Yeah.
Yeah, because you're adding 0. Then that means that you can split it up as, you can split up the integrand as x minus 1 over square root x minus 1 plus 1 over square root x minus 1 dx. But what is this guy over that guy? If you get a over square root of a, what is it equal to? Isn't this is just power 1, this is just power half. So it's just a power 1 minus half, which is a power half, which is square root of a. Agree?
Yeah.
So just to simplify things, it's just square root a. I'll erase all this working because it's quite confusing. Okay, I'm sure you know this, right? And a over square root a is just square root a. So that means x minus 1 over square root of x minus 1 is actually just square root of x minus 1. Correct or not? Replace the a with x minus 1. Can? And then you plus 1 over square root. Square root is power half, so it's actually just x minus 1 raised to the power of -half dx. Likewise, over here, the square root can change to a positive power half. Yes?
Yeah.
Maybe I'll just add in one more line. So this is integral of x minus 1 to the power of positive half plus x minus 1 to the power of -half dx, which is what they have over here. But they write it in the nice radical form, the square root form. Then you can just integrate. Just add 1 to get the new power. Half plus 1 is 3 over 2. divide by the new power 3 over 2. Likewise over here, for the x minus 1 to the power of negative half, add 1 to get positive half, divide by the new power positive half. Then don't forget a plus c. Okay? Then the rest is just algebra, you need to simplify. Okay? Divide by 3 over 2 becomes 2 over 3. Then divide by 1/2, just bring it on top, it becomes times 2. Then the rest is just factoring out. Do you understand what they're doing when they factor out x minus 1 power half?
Yeah.
Yes, then I don't go through
Okay.
this part here. Okay, then I move on to the second method. For the second method, what they did is they realized that square root x minus 1, I can just bring it on top straight away. Then I'll get x minus 1 to the power of negative. Oh wait, let me see what they're doing. I'm a bit confused. Oh, sorry. Okay, this one they're doing integration by parts. Can you see the table?
Yeah.
So what they did is algebraic and algebraic, which is what the extra PDF that I sent you. And I told you you can also do integration by parts when both of them are algebraic. So what they did is they pick u to be equal to x and dv by dx to be x minus 1 to the power of negative half. Do you know why there's a negative half here?
No.
Okay, because here x over square root x minus 1 is actually just what? X multiplied by 1 over square root x minus 1. Agree?
Yeah.
But what is 1 over square root?
Negative half.
Exactly. Yes, that's how you get your negative half.
Okay.
Yeah. Square root is positive half, bring up becomes negative half. So x times x minus 1 power negative half. So they pick x to be u, x minus 1 power negative half to be the dv by dx. Then after that, you just have to differentiate. You get 1, integrate, you get minus half plus 1 is a positive half, then divide by half, which is times 2. This one divide by half. Do you understand how you get out 2?
Yes.
Yes, okay, good. Then in that case, you can just do uv minus integral v du. So uv is here, minus away integral of v du is here. Okay? Times 1 means you do nothing. Then how do you integrate this one? Very simple, just factor out the 2, then integrate x minus 1 power half. So they just factor out the 2 here, but x minus 1 power half, you integrate, you add 1 to get the new power, divide by the new power. Okay? Then plus c. The rest is just algebra, it's the same as this step. You get the same answer. Just simplify. Okay?
Okay.
Okay, then the last step, what they do, this one even more complicated. They come up with their own substitution. You are not required to know your own substitution in A levels. It will be given. This method is not recommended. But let's just go through. Assuming the question gave you y squared equal to x minus 1 as a substitution, you can do implicit differentiation to get the derivative of 2y. Sorry, the derivative of y squared to be 2y. But don't forget a dy by dx tail. Do you know this tail idea? I haven't gone through Maclaurin series with you. I went through differential equation, but not Maclaurin series. So maybe eventually we'll go through it. You need to know this implicit differentiation, dy by dx. And then you differentiate the right hand side, x minus 1, you get a 1. Clear?
Yeah.
Differentiate y squared with respect to x on the left hand side. Okay, maybe I should write it out step by step. Sorry. What we are doing is we are differentiating with respect to x on the left, differentiating with respect to x on the right. So that means that we now have derivative of y squared over dx on the left. Then right hand side, I'll just simplify straight away. Differentiate x, you get a 1. Differentiate minus 1, you get a 0. So that's how you get a 1 on the right hand side. But for this guy, differentiate y squared with respect to x, you actually need to evaluate as differentiate y squared with respect to y first, then you times dy by dx. Notice that the y cancel off, dy cancel off. But what's differentiating y squared with respect to y? That's just 2y. Just pretend the y is like an x. Like x squared differentiate, you just get 2x. But now it's with a y. That's implicit differentiation. But don't forget that there's a times dy by dx tail. Always, implicit differentiation will always have a times dy by dx tail that's tagging along when the function is a y. Okay?
Okay.
Equals 1. Yeah, okay, good. Then how do we continue? So over here, we got integral of x over square root x minus 1. Then in that case, we can make x a subject, right? -1 bring over. So we get y squared plus 1 on the numerator. Numerator clear?
Yeah.
Good. Now we move on to denominator. Square root of x minus 1. How do we get that? Square root. Square root means the square root and y will cancel. Y and the square will cancel off. You're just left with a y. So y equals square root x minus 1. Right? Just square root both sides. So then you can get y over here. But how do you get dx to be 2y dy? Just make dx a subject. Yeah, so how do we do that? Just times dx over. So 2y times dy over dx equals to 1. I can bring the dx over. Oh, then I'll times dx. So that means 2y dy is 1 dx, which is just dx. So you can replace the dx with dy, 2y times dy. Y will cancel off. 2 can factor out. Then you're left with 2 times of the integral of y squared plus 1 bracket dy. Integrating this y squared plus 1, it's simpler, right? It's just y cubed over 3 plus y. Yeah, 10 plus c. But you now need to replace the y back with whatever was square root x minus 1. Can? Okay, can. Moving on. Next one, question 2. What happened? Wow, this one, something very wrong happening. Okay, a few mistakes. Number 1, you did partial fraction, it's okay. But then over here, the integrations, many mistakes. First one, integrating 3 over 1 minus x. Notice that 1 minus x, even though it looks linear, it's not such a simple linear. The ax plus b, here the a is a negative 1. All right, the coefficient of x is negative 1. So that means that you still need to use chain rule, you know? You need to divide by a negative 1. Did you know that? Did you know this? Like integrating 1 over let's say 1 plus x. It's not x squared, so it's just ln of modulus 1 x plus 1.
Yeah.
Okay, maybe I write it as a standard form. Here, if it's x plus 1, what's a derivative of x plus 1? It's just 1, right?
Yes.
Okay, but now let's take a look. If I have the integral of 1 over negative x plus 100 dx, what would it be equal to? Is it still ln of modulus negative x plus 100 only?
No.
Why? What's missing? Is the numerator the derivative of the denominator?
No. So like there should be a negative in front.
Negative like this, right? You must introduce 2 negatives like this.
Yeah.
So that now you get f prime x over f of x. Then you can integrate, you get ln. But since there's a minus in front, you just bring it down. Understand?
Yes.
Okay, now so same thing over here. We got 1 minus x, so you must have a minus. That's your first mistake. Okay? Second mistake. Over here, you got a 2x plus 1. Then what you did is you rewrite the plus 1 as plus 9 minus 8. Okay, that's fine. This is still true, but that's not very relevant. Because you see, I think what you wrote over here was differentiate x squared plus 9 equals 2x plus 9. That's wrong. X squared differentiate, you get 2x. 9 you differentiate is a constant. What do you get?
A 0.
0, not 9. Understand now?
Yeah.
Very major mistake. Differentiating 9, you get a 9. No. No, it's a 0. Okay. What is differentiation? Differentiation means you're finding the gradient of the line. Right or not? The rate of change. 9 is what? Y equals to 9. Is just a graph like this, a horizontal line. Then what's the gradient of this line?
0.
0 lor. A horizontal flat line. It's not steep at all. So it's 0. Okay. Can. So yeah, this is wrong then you get what? 9 over x squared plus 9. You get 9 ln of x squared plus 9. Oh, are you coming up with your own rules already? Ln only works if the numerator is a f prime of x. Denominator is x squared plus 9. You need a 2x plus 0 on the numerator. Then you can get ln. This is not correct. When you got x squared power 2 onwards, it's a quadratic denominator. Quadratic denominator, go back to the ultimate summary. Quadratic denominator, what do you need to do?
Complete the square.
No. Integration of a fraction. Okay, yes, actually. but you should look at the F in the LFP. Okay. Quadratic denominator already, or it's a fraction already. You need to first check is it proper or not. Then after that, you do LFP. Go through. Is it a L? Is it of the format f prime x over f of x? No, it isn't. That is a denominator x squared plus 9. You need a 2x to be the numerator in order for you to have a ln. So L is out. Clear? L is out.
Yeah.
Then now we move on to F. Which one? Which formula? You got quadratic function. Yeah, you complete the square. Yes, you're correct. Complete the square. But then which one would it be? Let's look at maybe you forgot already. It's an x squared plus 9. In fact, you don't even need to complete the square. It's already a quadratic and a constant. It's a plus. So which one is it? Minus, plus, minus, minus.
Okay.
Odd one out. There's only one single minus, right? So one single plus, right?
Yeah.
We should write down minus here, minus here. Then I'll put a plus here, minus here. So you should know straight away. Plus, there's only one correct answer, which is tangent inverse. Clear? Okay.
Yeah.
Okay, let's go back to. Oh, sorry. Let me find your question. Yeah. So here is totally wrong, lah. So I think we just look at the solution. Is that okay? Because it's getting quite messy. Okay, let's just look at the solution. So over in the solution, partial fraction, yes, you got the same answer or as the answer key, 2x plus 1 over x squared plus 9. Good. But what you should realize straight away is that x squared plus 9, if you differentiate, what do you get?
2x.
2x. You already got 2x. So you can split it up simply as 2x over x squared plus 9 and 1 over 2x squared plus 9. Right?
Yeah.
So that's exactly what they did. Okay, they didn't show the working. Okay, I write one more step. And also don't forget the limits of the integral. 3 over 1 minus x plus 2x first, you get x squared plus 9 at the denominator, plus 1 over x squared plus 9 at the denominator. Then after that, this guy is f prime x. X squared plus 9 is the f of x. Integrate, you get what? Ln of x squared plus 9 modulus. Okay? That's how you get the second integral. But the first one, 3 over 1 minus x, you actually get a negative 3 ln of modulus 1 minus x. But for the last one, 1 over x squared plus 9 is a standard integral. Just 1 over 3 times tangent inverse x over 3. Can use formula later, faster. Simple enough. Can? Okay, good. Then after that, you just need to sub in the upper and lower limits. Then you'll get this. Do you need me to show you?
Don't need.
Okay, you try on your own. Then you see whether you can get the same answer as them. You eventually simplify back to pi over 12 minus 2 ln 2. You need to use a bit of logarithm rules here. You see, ln 18 minus 3 ln 2 plus ln 18. Maybe I'll show you the working, and then minus ln 9. This one I show you the simplification because you might have forgotten how to use the logarithm rules already. I like to arrange it so that the positive is in front, then the negative is behind. Like this. And then there's a power 3 here. I mean, there's a 3 coefficient. I can bring it back up so it becomes a power. So 2 cube. Can see the 2 cube?
Yeah.
Then now you got a minus also. That means positive will stay on the numerator. You get ln of a fraction. Positive ones will stay on the numerator. So 18 stays on the numerator. Then minus ln 2 cube means you have a 2 cube at the denominator. You minus another ln 9 means there's a times 9 at the denominator like this. Clear? It's a shortcut. It's like ln A minus ln B minus ln C is equals to ln of A over B times C. Basically, if you have a bunch of plus, 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 and then plus, and then minus, minus, minus for the ln, the plus will stay on the numerator, the minus will stay on the denominator. Does that make sense?
Yeah.
Can So if like, for example, if I add on a plus ln D, how would you modify this? Where will the D go? It must be on the numerator, right? Because it's a plus sign, so you have to times a D. How about if I minus a ln E? Where will the E go?
To the denominator.
Times e, exactly. You get the pattern already. Oh, that's just a recap on logarithms. That's how they get this guy, 18 over 99 over 8. 2 cube is 8. Don't forget that plus 5 over 12. Sorry. Forgot to write it down. Plus 5 over 12, plus 5 over 12. Okay. Simplify, you eventually get this. Can? 1 over 4 is 4 power negative 1. Or rather, maybe I just write down. 1 over 4 is the same as 2 power negative 2, right? Then you can just ln this, then power can go down. So negative 2 times ln of 2. Negative 2 times ln 2. Yes?
Yeah.
Okay. Good. So moving on. That is question 2 done. Then question 3. Let's see your answer for question 3. I can't remember. What do you do? Oh no. Oh no. This one, at least you finally remembered to change the limits. Okay. First time that you remember. First time that you remember to change the limits. Good. Then here got a problem. Still incomplete. Dx, you must replace the dx with du. Replace the dx in terms of u and du. Right? I show you ultimate summary. I already mentioned this. Ultimate summary is in the last part. Part. Actually, did I mention this? Did I not mention this? I did. Part D, sorry. Integration by substitution. Right? You have to convert your x1 and x2 into u1 and u2. You have to bring it from the x world to the u world. Okay? And then over here, dx must change it into dx over du times du. Do you see that?
Yeah.
So it's now the du world. From dx, convert into the du world. Eliminate x, eliminate dx. That's your 2 steps. You didn't do step 2. Do you see that? You forgot to do step 2. Are we clear? Mic test.
Yeah.
Oh. Can not too confused, huh? Okay,
Yeah.
so that means everything else is wrong. So let's just look at the solution. Okay, do you need to rush off?
Don't need.
Don't need, Okay, let's take a look. Substitution u equals square root x plus 2. Then otherwise show that the integral of this guy is ln of 3 over 2. So let's see how they did it. So you start with u equals to square root x plus 2. Square both sides, you get u square equal x plus 2. Differentiate, what do you get? Here they make x the subject. The plus 2 bring over. So it means that we get x equal to u square minus 2. Then from here, you find dx by du. So you become u square differentiate with respect to u, you get 2u minus 2. Minus 0, sorry. 2u minus 0. Is this clear?
Yeah.
So if you're confused, just think of it like y equals to capital X, capital Y equal to capital X square minus 2. Then you're doing d capital Y over d capital X, which is 2x minus 2. Right? It's just that capital Y is now a curvy X, capital X is now a U. Okay, Y is X, X is U. All right, then that's how you get 2U. Okay, then now you find the upper and lower limits. Yes, you got this, you got a 2 and 3. I don't talk more about it because you got it. Maybe I'll just add on the extra x equal, and u equals, just to remind ourselves that we have successfully converted from the x world into the u world. Not done yet, because here the x, you now need to replace with it with expressions in terms of u. You managed to do that for the denominator, that's good. But for the dx, you forgot to replace with 2u du. Okay, actually not just forget. Take a look at your working here. You realize that du by dx, it's in terms of x, right? But you actually need this to be in terms of u. So what you need to do is to realize that x plus 2 is actually u square. So you can actually replace the denominator here with u square. Do you see that? There's one more missing step for you. So you need to take a square root of u square, which will eventually become a u. So 1 over 2 times u. Then after that, you can make du the subject. Do you understand what I'm saying?
Yeah.
Okay. You sound quite tired.
No, I'm trying to see.
Okay, so I'll just show you. This one becomes 1 over 2 times square root of, we know x plus 2 is what? X plus 2 is u square. So you can replace with u square. Can you see that?
Yeah, can.
Then after that, simplify, you get a 1 over 2u. So if you want to replace the dx, you need to make dx a subject. So let's just cross multiply. So du equals to 2u du equals to 1 times dx. Okay, better not write the times, just 1 dx, which simplifies to dx. Is this clear?
Yeah.
This one cross over, that one cross over. Maybe I don't make it so confusing. I write it in a standard way. I should write down the fraction on the left, fraction on the right, equal sign in between, cross. I think that's more obvious.
Yeah.
Yes, all? Can
Mm.
Then get 2u du equals to 1 times dx. Then now that you have dx to be 2u du, you can just sub in. Then your working would have been fine.
Yeah,
Right?
I forgot to sub in.
Yeah, step 2. Remember, must read the ultimate technique, ultimate summary. This one. Step 1 and step 2 and as well as a step 3. In this case, there is a limit. So yeah, you did step 3, you did step 1, but you forgot to do step 2. Okay, that's your problem. Forgot.
Yeah.
So please read the solution. The summary. Okay, moving on, let's go look at the rest of the solution. So yeah, x plus 1 here is u square minus 1 because plus 2, if you want plus 1 instead, you should just minus 1 on both sides. So you get u square minus 1 equal to x plus 1. That's how they replace it with u square minus 1. X plus 2 here, square root x plus 2 here is just a u. Okay, then what happens? U and u can cancel off, right?
Yeah.
Then you are left with 1 over u square minus 1 times 2. So that will be, what would it be? What happened to your 2 here? They didn't write down a 2. Oh, they were integrating. Over here, you get a u square minus 1 with an extra 2. That means that we can use standard formula. Or alternatively, we can do integration by partial fractions. So 2 over u square minus 1 is what we are trying to integrate. So we're going to do partial fractions on this 2 over u square minus 1. Oh no. So 2 over u square minus 1. Simplify, we get 2 over u plus 1 u minus 1. Then we'll get a a over u plus 1 plus b over u minus 1. Let's see what we will get. So in this case, we'll get 2 equals to a times u minus 1 plus b times u plus 1. Then let u equals to, let's say 1, we'll get 2 equals to 0 plus 2b, implying b equals to 1. If we let u equals to, let's say, negative 1, 2 will be equals to a times minus 1 minus 1. That's a minus 2a plus 0, implying that a equals to negative 1. So we can just directly replace a with negative 1, b with a 1. That means that if we try to, let me just copy and paste to save some time. Copy and paste, integrate this guy, du, it's really the same as integrating our partial fractions with respect to u. So this will give me a ln of modulus u plus 1. But don't forget there's a negative 1 numerator, so put a minus in front, right? And then you add on ln of u minus 1. Positive here, negative there, so you can combine into a single fraction, ln of modulus u minus 1 on top, u plus 1 below. Okay, that's exactly what they got here. Can? Okay, good. Then after that, you can sub in the limits 3 and 2. So you get the 2 over 4 minus ln 1 over 3, ln 2 over 4 minus ln 1 over 3. Simplify, you get ln 3 over 2. Clear?
Yeah.
Okay, good. So this one, I'm sure you can calculate it on your own. Minus will become a division or divide. Then that is the first part. Show that this guy equal ln 3 over 2. Not done yet. You want to hence find the exact value of this expression here. So can you tell me how they are similar?
The denominator.
Exactly. Denominator is the same. So there's just an extra x minus 1 multiplied. So do you realize that this is really just x minus 1 multiplied by x plus 1 times square root x plus 2?
Yeah, but cannot split up.
Yeah, you cannot split up, but it's whenever you see a product, you must think, doesn't this look like a u dv?
Oh. Yeah.
Right? So you're gonna use what? Use what technique?
Integration by parts.
Exactly. And if this is dv by dx, right, That means we need to find v. We need to integrate it. Do we know how to integrate it?
Yes, the previous.
Yes,
one.
exactly. We already integrated it. That's why this is a hence question. This is a trick you need to see. Okay, you can split it up as a product of x minus 1 times the other stuff. The other stuff being something that we already calculated. We already have an answer. And that's how we can use the answer from the previous part. Can understand?
Can.
Can now? Okay, so that's what we're going to do. Oh, how come I put down a 2 again? Should be a 7. Yeah, so that's exactly what they did in the solution. Let's see how they did it. Oh, sorry. That's not what they did. They did something different. Okay, I think my method will still work, but a bit more long-winded. Oh, they did a different method. Sorry. They did something clever here. They rewrite -1 as +1 minus 2. Yes. Oh, okay. Can. That works as well. Yes. Okay. Let me try again with their thought process. What they did is they realized that we know how to integrate 1 over x plus 1 multiplied by square root x plus 2. So that means that we also know how to evaluate a scalar multiple of it. So let's say if this one times 2, I just need to times 2 here, right?
Yeah.
So any scalar multiple, it doesn't have to be 2, it can be 200 and just times 200, right? So that's why, I just erase this. Here they did something clever. They replaced the -1 with +1 minus 2. Why did they do that? Because they realized you can group the x plus 1 together and it will look like the denominator. Then over here, then after that, they split it up as x plus 1 minus 2 over the same denominator, x plus 1 multiplied by square root x plus 2. Like this. Is this clear?
Yeah.
Then what happens when you got x plus 1 on top and bottom?
Cancel out, become 1 over.
1 over square root x plus 2. Yeah. Then this one becomes a -2 over x plus 1 multiplied by square root x plus 2. So we can split it up. Integrating this guy, we will get a positive square root. Reason being, 1 over square root x plus 2 is actually just x plus 2 to the power of -½ So if we integrate dx, we just have to add 1 to get the new power. So -½ plus 1 is +½ Divide by the new power, +½ Divide by half is the same as multiplying by 2. So x plus 2 to the power of +½ which is really just 2 times square root x plus 2. That's how they got this answer here for the first term. Okay? This becomes this. Then you must put in the limits, 2 and 7. Then over here, they immediately got 2 times of ln 3 over 2. Do you understand what they're doing? Why? How did they calculate so fast?
From the previous part.
From the ln 3 over 2. If you times 2 here, you also times 2 here. So just 2 times of ln 3 over 2. Take note that 2 times of ln 3 over 2 is not equals to ln of 3 over 2 times 2. Not the same, okay? This ln 3 over 2 is like, this 3 over 2 is inside the ln. It's like protected. The 2 copies is outside the ln. Are we clear on that? The 2 cannot go in.
Square?
Yes, it is square instead. Yes, it should actually be 3 over 2 square, which is ln of 9 over 4. Totally different from 3 over 2 times 2, which is ln 3. Okay? 9 over 4 and 3 is very different. Can? Okay, good. So yeah, then now you can just sub in upper limit, sub in lower limit, then minus. You eventually simplify down to a 2. Can? Can? Okay, moving on. That was question 3. Question, what else have you done? Question 4 or no more already? Okay, can. All right, so you still got a bunch of other questions to deal with. Question 4 onwards. I also want to assign you another integration techniques worksheet. It's on the prelim questions. Then that will be all for today. I guess I will go through the application next week. Is that okay?
Can.
Application will be on the volume of revolution, if you remember. Like you turn around our axis and get a cone.
Yeah, that one very hard.
Oh, no, very simple one. You just need to know that you got this guy as a function, like x comma f of x. And this guy here, let's say, is the same x but 0. You just need to take you just need to follow the formula, fx minus 0 in this case. Then you take a square, multiply by pi, take the integral. It's just a formula. The trick here is to realize that a volume of revolution, you can think of it as chopping it up into many cylinders. Okay, if you can visualize. Then how do you find the volume of a cylinder? It's just pi r square for the base, and then you multiply by the height, right?
Yeah.
This is h. Okay, pi r square h. Then how do we get the radius here? Pi r square times h.
The y value.
The y value. You just need to take the radius. The radius is over here, if you can visualize, from maybe from here to here. And that's just the y value. Or in other words, there's this graph at the top here, and this graph at the bottom here. In this case, it happens to be the x-axis. So we just need to take y equals f of x, and y equals to 0. This is like y big, this is y small. How do you find the radius now? Just take y big minus y small, which is fx minus 0. Right?
Yeah.
And then you get your radius, pi r square h. But here h, the trick to calculus, or what we call differentiation and integration, is actually in university calculus. The trick here is to take a very bad approximation of a cone. Let's say you want to find the volume of a cone. It's really just one such cylinder, right? But you notice that there's like a gap over here.
Yeah.
If you draw another cylinder, I show you another cylinder. Wow, testing my art skills. And then draw another cylinder like this. And then you connect them together like this horizontally. Sorry, my cylinder a bit too tall already. You realize that, oh, let me just extend this a bit more. I think I should make it straight so that I can be more accurate. I think you can see that there's still another gap at the top here, as well as the bottom.
Yeah.
Then, and the top and bottom is actually going one full circle. So this is what we call approximation of the cone, right? If you take a cylinder, you add on another cylinder, and you add on many copies of these cylinders, you'll get an approximation of the cone. Yes?
Yeah, but then the gap, never mind.
The gap will disappear, can be proven in university. You don't need to know. But for now, you just need to visualize. The gap will eventually tend towards 0 if we introduce an infinite number of these cylinders. How do we introduce an infinite number of these cylinders? By making the width here, which is really just the h here, the h of the cylinder. It's just that I topple it 90 degrees. Making this width here, instead of calling it h, we call it dx or delta x. Delta x. And if we let delta x go towards a very small value, towards 0, it means it becomes a very thin cylinder. Can you see that?
Yeah.
It's like a bunch of coins that are stacked together. If you stack a bunch of coins together very thinly, you can eventually get a cone, right? Can you see it? Can you sort of visualize? Like do a few more dot until eventually you get to a smaller, super thin cone. You eventually get this shape here, which is sort of like a cone. It's just that there are gaps. There's a gap, there's another gap, there's another gap. A gap here, a gap here, a gap here. But if we introduce an infinite number of these cylinders, the gap will eventually drop to 0, and it will be exactly equal to the area volume of a cone. Are we clear on that? So over here, this delta x is okay. So how do we get the volume? Volume is really just summing up summation notation the volume of each of these cylinders, right? So it's really just sum of pi times r square times this delta x, which is my height here. I replace the h here with delta x. And then after that, you just need to realize what's a formula for the radius. It's just the y big minus y small. In this case, let's just deal with the simple case where you rotate the cylinder with y equals f of x about the horizontal line y equals to 0, also known as the x-axis. And f of x, maybe it's a linear function, just a straight line. Let's say y equals x. Then if you want to find the total volume, isn't it just pi r square h but you add up all of the possible heights, all cylinders.
Yeah.
Okay, good. Then in this case, how do we specify all cylinders? Of course, you don't write down all cylinders. You actually need to index each of the f of x, because here there is one possible x1 comma fx fx1. Then here there's another possible height. If you can see over here, there's another possible height. This is another y coordinate. This is maybe fx2. Oh, my diagram very bad. Let me try again since I'm already explaining this. Let me draw it nicely. Okay, let me get rid of this ugly diagram. I'm just gonna make it look nicer. Then I reflect it like this, roughly. Let me just double check. I need a circle, then I need the radius. I can just center it roughly. Okay, so it's somewhere like this. How do I bisect it? I need to double check that they are roughly the same. If I draw a vertical line directly below, then I can bisect it. So let me just adjust this a bit. This will be perpendicular. Okay, and then I draw a line like this. And doesn't look very centered. Okay, you know what? I shouldn't draw here. Are you rushing off?
Oh no.
Okay, I show you how I draw. Okay, let me start a new piece of paper. I need grid paper. It's easier. Okay, so paste it here. Yeah, starting a new theory lesson. Okay, so this one bring over, this one bring over, this one bring over as well. I'm gonna draw a nicer picture. Hold on a second. Maybe I'll extend until here. And this one, maybe I'll extend it until here. This is my y equals to x. Can you see a cone shape?
Yeah.
Okay, maybe I will try to make it a little bit more less slanted. So something like this. Okay, let me count now. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. So somewhere here. You just draw a line like this. Then you get a cone. I think this is nicer. Right? You can see the cone more easily.
Yeah.
There are many circles. So what we're gonna do is, how do we get this is y equals to, let's say for example x, and that will be y equal negative x. We're trying to find the volume of this guy, right? So what we're really doing is we are starting off by chopping off a cylinder here. Okay. Something like this. Maybe I should have drawn it more like this. Can you see a cylinder?
Yeah.
Dotted line means it's behind. This one cylinder, I think is quite obvious. But you can see that there's a gap here. Tiny little gap. Tiny little gap here. How do we get the radius? It means this height here. Can you see? Isn't it just this function f of x? I'll call it f of x. Minus away 0, where 0 is this guy here.
Yeah.
Can you see or not? Here is f of x. Here is 0. So you just take big minus small, then you get your height. That's your radius. Then how do you find the volume of this cylinder? This pancake. This height here, let's call it delta x. Well, it will just be pi r squared minus, times delta x. Right? Pi r squared will give you the base area, and then you multiply by the height. Or in this case, the height is horizontal. So r squared will be fx minus 0. Then what we realize is that this is for each x, right? If let's say I call this over here x1, this will actually be f of x1. Here, over here is f of x1. Here will also be f of x1. Here will also be a x1. And here will also be a x1. Correct or not? Can understand?
Can.
X1 could be like for example 4 lah, huh? Like 1, 2, 3, 4, 5, 6. It could be 6. Then over at maybe this is 7. I can draw another cylinder. Okay, I draw another cylinder like this. Assuming that it overlaps exactly, then it will look something like this. Like this, and then you have a horizontal line, and like this. I was just really testing my art skill. Something like this, and then there's another dotted line like this. Can you visualize the cylinder? Can you see the other cylinder here? It's like a coin here, and then you have another coin stack below it. Can you see? Mic test. Can you hear me? I cannot hear you.
Sorry, I cannot. Wait.
Sorry?
Oh, I think my mic just now got problem.
Oh, okay. Can you hear me now? I mean, can you reply back? Oh, sorry, I cannot hear you. Mic test, can you hear me?
No?
Yes, I can hear you now.
Sorry.
Can I? Oh, so do you understand? If I draw another cylinder here,
Yeah.
does it make sense? Of course, I can keep on going, right? I can draw another cylinder, and another one, and another one, and another one, and another one. Then eventually, if I add up all of the volumes of these cylinders, I will get the entire approximation of the volume of the cone, right?
Yeah.
Okay, good. So let's figure out a formula. In this case, if this guy over, let's say over here, oh, maybe I should zoom in. If this guy over here is my x2, then what will be the radius over here? Let's call it cylinder 1. That was cylinder 1. Cylinder number 1. Then that guy is cylinder
2.
number 2. So what's the volume of cylinder number 2? Pi r squared times, let's say the width, we fix it to be the same width. I mean, oh no, my y-axis. Okay, bring back. Okay, we fix the width here to be delta x. Delta x is just some funny symbol to represent a fixed width. Then it will just be f of x2. F of x2 minus away 0. Make sense? Because the y coordinate here is x2 comma f of x2. And the y coordinate here is x1 comma f of x1. So it means that your x2 is actually, okay, you need to be a bit more precise. Something like this. Maybe I'll draw a broken line to make it look nicer. So over here, it will be f of x2. Then what will be the height? It will just be this length, right? Which is fx2 minus y 0. Then you get your radius. This is radius. Okay, good. So now you got the radius times delta x. Again, it's a fix. Of course, you can keep on going on volume of cylinder number 3, number 4, number 5, number 6. Then the key idea here in calculus is that we want to make use of this number, or not a number, this idea known as infinity. What we want to do is to get the volume of total, which would be just this formula, pi times radius square times delta h. But now we replace x1, x2, x3 with xi, and then we take a summation, I equals to 1 to infinity. Does that make sense?
Yeah.
That makes sense. Okay, very good, very good. So it means that we're gonna have all the possible index. I go to 1, I go to 2, I go to 3, I go to 4, all the way to infinity. That means we'll have an infinite number of these cylinders. And then eventually it will be exactly equals to the volume. We can disregard the error, the under approximation. It will eventually go to 0. It can be proven if we take infinite number of these. cylinders. Okay.
Mm.
Then here notation wise, actually what I'm introducing now is something in university already. Actually, it's in further math, but I'm just gonna tell you anyways. Just visualize that. This is called a Riemann sum. And you can rewrite it. Let's say we factor out the pi. Then what will we get? We'll get pi times the sum of the same radius square, but times delta x. Can?
Can.
But this summation on the left and the delta x on the right, doesn't it look very similar? If my delta I show you you just somehow curve it. Doesn't it look like an integral? Delta x. Delta x. Delta x. Doesn't it look like a dx? It's like Chinese, the history of Chinese characters, evolution. Same, right? Looks the same, right?
Yeah.
And by definition, it's in university already. This is equals to pi times integral dx of fx minus 0 square. And then you need to sub in the limits. Because now in summation notation, we can plug in x1, x2, x3. But in that case, it will just be, if let's say I start from this guy to be A and end up with B, the limit it will become A to B. And that's the formula that you should know for the volume of revolution. Pi times the integral of the radius squared dx. Dx is like your height, h. Okay? A to B. But the radius in this case, why did I purposely write down fx minus 0? Why do I just fx? Fx minus 0 is just fx. Why do I want to put a minus 0?
You sure
Because...
initial.
Sorry? Sorry, do you say something?
Oh, I don't know.
Don't know. Okay, I explain. So in this case, it's because I want to see the general formula. Here, I ask you what is the radius, what's the radius to get the volume of the cylinder. But let me ask you, if you have a donut, how do you find the volume of a donut? Let's say that there's a donut like this. There's a ring, maybe cut through like this, for example. Can you imagine that it's hollow inside? Donut. Then let's say that the radius here is 5, and then the radius here is 1. And let's say the height here is 2. Oh, then what's the volume of this donut? V donut. It will be the volume of the big minus volume of the hollow region, right?
Yeah.
So what will it be? Pi r, sorry. Radius, the radius here, right? It's the big R, this one is a small r. So pi 5 square times height h minus y pi r square times height h. Does it make sense? Volume of cylinder minus volume of cylinder.
Yeah.
Factor out what? The pi. Factor out the 2. What do you get? You end up with 5 square minus 1 square. Can you see that?
Yeah.
Pi times 2 times 5 square minus 1 square. So if I can figure out why do I have a 5 here? It's maybe because if I can just rescale my diagram a bit. Maybe it's possible that there was a x-axis that passes through this hollow region, and then there was a graph that looks like this. That looks like this. And then there was another graph, a pink color graph, that looks like this. That looks like this. And we're asking you, what is the volume of revolution of the region that is bounded in between the pink line and the blue line? Then you rotate. That would be a donut. The question will phrase it like this. There's a y equals maybe like, let's say for example, y equals 5x. Then let's say this is y equal to x. Okay?
Yeah.
Then let's say that this x coordinate here is a 1. Can you see the 1? This x coordinate here is 1. Then that means that this point here, what's the height? It will just be sub in x equal to 1, so y equals to 1. That's how I get a height of 1 here. How do I get a 5 here? it's actually just y equal to 5x. You sub in x equal to 1. So y equals to 5 times 1, which is a 5. That's how I get the radius of 5 here.
Oh,
In general, it's not just 5 square minus 1 square. It's 5x minus x, bracket, sorry, 5x square minus x square, then times pi, then times 2. But that is only for one such donut. We want all the donuts, let's say from a point A to a point B. Can you visualize all the donuts added together?
yeah.
Very hungry, you want to eat many, many donuts. You get all the donuts. Oh, this entire region here and here. Then that just means you need to take the integral. Instead of 2, it will change now. No longer a 2, it's a dx. Sorry, it's getting a bit messy. Let me write it neatly. From A to B, right? So in other words, if you generalize further, we call this f of x. We can call this g of x. It will be pi times the integral from A to B of f of x, the upper region, square, minus away the lower region, square, dx. This is the general formula. This is the radius. Okay? Can?
Yeah, can.
So maybe I shouldn't have written it as bracket square. It's better if I write it like this. Fx square minus 0 square. Fxi square minus 0 square. Fx square minus 0 square. Why is it possible? Because bracket like this. Bracket. Reason being, you can think of it like this. Here is fx1. There's a y equals to x. Here is a y equals to 0. There's a fx1, a gx1. Maybe you can think of it as this coordinate here is x1, gx1, where gx1 is just equal to, it's on the x-axis, so it's equal to
x1,
comma, it's on the x-axis, so what's the y coordinate?
x.
Let's say you don't use x1, let's say this is 4.
4,
4, comma, what's this coordinate?
0.
0, yes, it's 0. So in other words, this g of x is just 0. So actually, we can think of it as the radius here is fx1. Then you square it to get the volume of the cylinder, minus away 0 square. There's a volume of a cylinder that has 0 radius, which is nothing. So that's why we can have a fx square minus 0 square. Fx square minus 0 square to get the radius, the full radius. Can okay? Can yeah, so that's the general formula you should know. Usually in schools, they will just ask you to memorize this formula. Here, I'm trying to give you an explanation. You just need to visualize. It's like pi r square times h minus away pi r square times h. Volume of big minus volume of small. And then the integral here dx is just asking you to add everything together because of the evolution of the summation. I know it may be confusing, this part here, but it's not in your syllabus, so you don't have to worry. You just need to remember the intuition behind it. Okay? This formula. Summation is because you're adding up many of these cylinders. Then r square minus r square again is because you're taking big radius minus small radius square. Okay, that is one of them for application. Later on, you'll also learn about the parametric one. X equals to, like, for example, a sine t, and y equals to b cosine t or something like that. Then they want you to find the integral of y dt from y dx from x equals to 2 to 3, for example. Then what do you need to do? This is substitution. You need to convert it from x to t equals something, t equals to something. Then your y has to be something in terms of f of t. Maybe more like y here, then y has to be in terms of t. So maybe b cos t. Then dx, how do you find dx? It's the same as substitution, right? You need to differentiate. So dx by dt, sorry, dx by dt. Then you need to make what a cos t. Then after that, you can make dx the subject by making a cos t dt by bringing the dt over, so you get a cos t dt. Then you can sub in that kind of thing. I'll go through in detail next lesson. If we have time. Then yeah, then after that you can just continue. So it's just like substitution. Okay, application.
Okay.
For now, I will assign you. Okay, this is the, maybe I should label this. This is volume of revolution, intuition behind the formula. If you have no intuition, you have to be very good at memorizing.
Okay.
Behind the formula. The ultimate formula is over at the bottom here. This is the conclusion. I hope you got some intuition. If not, never mind. Just memorize. Oh.
Okay.
Okay, this one. Okay, my favorite formula. Must memorize this one. Okay, Ken, then I'll just assign you your homework later. Then yeah, you'll do the rest. You'll do the more practice on integration techniques. Okay? Ken, and I didn't go through with you. Wait, let me see. What question do you do? Sorry, not this file. This file? You haven't do question 4, 5, 6, is it?
Yeah, I haven't.
Okay, Ken, and then you that will be your additional homework in addition to what new worksheet I'll be giving you. I think I already sent you.
Okay.
On the revision package. Yeah, prelim revision package. Okay, that's all for today.
Okay.
Ken?
Thank you.
Thank you.
Okay,
Go work. Ken, thank you. Bye-bye.